Congratulations on completing the course. Thank you once again for taking this course. Please remember to keep me updated on your progress or anything else that I can help you with. Meanwhile, here are my other courses which might interest you. Number 1. Learn ethical hacking by hacking real websites legally, Part 2. Learn ethical hacking by hacking real websites legally, Part 1. Internet of Things, IoT, Robotics, and Hacking with Node MCU. How to monetize your Construct 2 games using AdMob Ads 2020. Android mobile app development with Onsen UI and PhoneGap. Monetize your mobile PhoneGap apps using AdMob Ads 2020. Create mobile app icons using Inkscape. That is all from me, and I wish you all the best and hope to see you again in my future courses. Thank you. Hello and welcome. This is the website for Frida where it all begins. And you can see the link on the left top corner here, frida.re. So what is Frida? Frida is a dynamic instrumentation toolkit for developers, reverse engineers, and security researchers. It is scriptable. You can inject your own scripts into black boxes processes, hook any function, spy on crypto APIs, or trace private application code. No source code needed. You can edit, hit save, and instantly see the results, all without compilation steps or program restarts. It is also portable. It works on Windows, Mac OS, Linux, iOS, Android, and so on. So this is the power of Frida, and Frida is always free, and it is also a well-tested program toolkit, and you can download it for free as well. So what are the advantages of Frida? Frida uses the REPL concept, also known as the read, evaluate, print, and loop. So what this means is that you can intercept and hook any API or functions inside a running process and inspect its parameters as well as its return values, and you can also temper or modify them to your liking. And the power is also in the scripting capabilities. You can extend the power of Frida using scripts. You can write scripts and then run those scripts and perform whatever modification of the running process to your heart's content. So the possibility of runtime tracing includes tracing classes, methods that belong to the classes, and the parameters or arguments for all those methods, and also the return values of those methods. So this is an introduction to the high-level concept of what is Frida, as well as its power of the Frida toolkit system. So thank you for watching. I'll see you in the next one. Hello and welcome back. In this video, I'll explain to you how the Frida system works. So in the previous lesson, I already explained the basic concept. So over here now, we'll look in slightly more detail. In this diagram here, you will see that it involves two devices, your PC and also the Android device. So the Android device can be either an emulator or a real physical device connected to your PC using a USB cable. So if it's an emulator, the device will be rooted, and if it's a physical device, most likely the device is not rooted. So in either case, we'll need to insert a Frida server onto the device and run it, because the Frida server is the component that injects all the commands as well as the scripts into the process of the APK. So over here, we need to have the APK process running, and then the Frida server will communicate with the APK process by injecting some scripts or commands into the memory of the running process that we are targeting. And then the communication is bidirectional, meaning two-way. So the Frida client will be communicating with the Frida server. So whatever command we execute in the Frida client in the PC will be then sent to the Frida server, and the Frida server will then inject it into the running process. So this is the high-level architecture of how we are able to inject the Frida service, the Frida script command into the APK process, and also temper or modify or analyze the parameters of the functions or methods that are running inside the APK process. And the Frida client is run through the command line interface, which is a command prompt in Windows. Now on the Android device side, if the device is an emulator, therefore it will have been rooted, the Frida server can be installed easily just by pushing it into the Android device. And then after that, all we need to do is just run the Frida server in the background before we start any session. And once the Frida server is running, we can then run our Frida client to connect to the server and send commands to tell the server what we want to do, whether to start the process, the target process, and inject commands or whatever it is that we intend to do. However, if it is a physical device that we are using, chances are it will not have been rooted, and therefore the technique of inserting the Frida server is different. So if the Android device is a physical device and it is not rooted, then we will have to rebuild the APK process in the PC first by rebuilding it with the Frida server embedded inside it, and then we'll have to install the modified APK into the Android device, so that when the when the modified APK runs, inside it there will be an embedded Frida server, which is called a gadget, will then expand itself into the memory of the running process, and then it will run as a Frida server using the APK's process memory. So this is the differences between Android device which has not been rooted as compared to an emulator which is usually rooted. So that's all for this high level explanation on the details of how we can inject and perform analysis and reverse engineering using Frida on the Android devices. So that's all for this video. Thank you for watching. Hello, welcome back. In this video, I'll show you how to install a Android emulator called LD Player. So head over to this website and click the download button. Now we are going to scan the virus total. Just drag it into virus total and you see there are 4 hits. These are not serious, just ignore them. It will run okay, don't worry about it. So now we are going to open the installer by double clicking on it. Click on the setup path and take note of the location where it will be installed to, and then click on the button install. Here you can reject the additional Avast antivirus and now it will download some files. Let it install, and now it's finished installing, and click start to launch the LD player. So the LD player is faster and more stable than the Android device emulator that comes with Android Studio. It is also easier to use and has a better display. That is the reason why I'm choosing to use LD player. So this is what it looks like. It is in landscape, but you can also change the portrait mode. Let's do some settings by clicking on the settings button. We want to click the other sections, and then we want to set it to be rooted, so click on root enable, and then here select ADB debugging, select open local. So these two are necessary in order to use our device, our emulator. ADB, later on I'll show you. So just click confirm everything and click restart now. ADB is used to manage and also to transfer files, and also to do our analysis on the device on the emulator itself. So that's how we install LD player Android emulator. Thank you for watching. We are now going to install the platform SDK tools. So head over to this website here, and then download the SDK platform tools for Windows, and then scroll down and click on the checkbox, click download button, and let it download. Platform tools contain ADB as well as other important tools we should be using, but mostly it's ADB. Click on the download folder and cut the downloaded file and put it in the special folder of your choosing. I will just put it here. So now I've pasted my file there. I will unzip it. And then I can delete the downloaded file. I don't need it anymore. So this is the unzip folder, and inside you will see ADB exe, the important tool that we need. Now we need to create an environment variable path to this path, so that we can use this command from anywhere in our file system. So copy the path, and we are going to create a new path to this location. So search for edit environment variables and open it, and then click on the path, click edit. You can also click on new, but the other way is also to click on edit, and then click on new and paste the path that you have copied. Hit enter. Now you can move it up if you prefer. So you move it up so that it is easier to find. Click OK. Click OK again. Click OK again. Now we can open a command prompt. Click on the command prompt, and we can test it out now to see if it can be found. So just type the command ADB help, and it managed to find it. So our environment path is correctly set, and now our platform tools has been installed. Now we are going to test with our emulator. So run your LD player. So you can type the command ADB devices, and you can see the emulator 5554 is referring to our LD player, and you can connect to it using ADB-S and the name of the emulator followed by shell. So hit enter, and you will find that you have a root shell. Type ID, and you can see that you are root. You can now type the command cat and then proc CPU info to find out what is the processor for this emulator, and you can see that it's an Intel processor. So basically you can run any Linux command. As you know, Android is a Linux operating system. The hash sign shows your root. You can also confirm that type who am I and you see it is root. You can also type ls to list all the files in the current directory. So it is working, so we have successfully installed our ADB and tested it. Thank you for watching. Welcome back. In this video, I will show you how to download the Frida server. So go to this website and scroll down, click on the releases page, and it will open up the GitHub for the Frida server. So just scroll down, look for Frida server for Android x86. This is the one, so click to download it. Open the download folder. So let's cut it and put it in the proper place. So I'll create a new folder called tools, and I'll paste the downloaded file in here, and then I'll unzip it with a 7-zip, and this is the one. So let us rename it. Just call it Frida server. So make sure your LD player is running. We are going to install it. So first we have to change to the folder containing the file, the Frida server. So just type your cd change command, change directory command, and enter your tools folder. Type a dir to list the directory and you will see the Frida server there. So run adb push, but before that let us check to see that our server is running. So type adb devices to confirm that your device is running, your emulator is running. Now you type adb push Frida server, and then the directory, which is /data/local/tmp, and then hit enter. So now you see it has been copied over to that folder. That is the world writable folder in your emulator. So now you can connect to it, adb shell, connect to your emulator, and then you can change to become a root by using su, but if you are using LD player you don't have to do that, you are already automatically root. So now change to the data local temp folder, list it, and you'll find Frida server there. So to run the Frida server, just type, but before you can run it, you list it to see whether it has got the run permission. ls-l is to list, and you see it is not runnable, not executable, so we need to change mod +x to make it executable. Now you list again and you can see it is executable. It has got the x at the back, so it means it is executable. So now let us run it as a background process by typing /Frida and put the ampersand at the back, hit enter. And now to confirm that it is running, we will do a listing by typing ps. So ps will list all the running processes, and you can scroll down and look for the Frida server to see if it is successfully started. If you scroll down, you should be able to find it. Frida server. Yeah, that's the one. So it's confirmed it's running. There's another way to quickly check. You can type ps, that is type ps and then type a pipe command, pipe and then type grep frida-server. Grep is to search, pipe is to redirect the output from one command to a second command. So you're piping the process listing output to the find grep command and the name of the string that you want to find, which is Frida server, and you will find it there. So this is a faster way to search. So that's how you install Frida on your Frida server on your emulator and how you run it. So that's all for this video. Thank you for watching. Hello and welcome back. In this video we are going to install Objection and Frida client. So head over to the Objection website, click on Installation, click on Prerequisites. It says you need Python version 3. So we are going to install Python first. So go to the Python website here, click on the download button and wait for it to finish downloading Python. Now the Python installer is completed downloading, open the download folder and double click the installer. And before you click install now, you need to go down to the bottom of the screen and click on the checkbox to add Python 3 to the path. Then only click install now. So just wait for it to install Python 3. So successful, click close. Next, we will check whether it was successfully installed. So you open a command terminal, reopen one so that it will reload the environment variables, and then type the command python-V and it confirms the installation. Then type pip -- version to check whether pip was installed. Pip is a Python package manager. It is used for installing new libraries for Python. So now we can download and we can install the Objection program. So Objection will also automatically install the Frida client. So this is how you install it. Type pip4 install -u Objection. pip3 install -U Objection. Hit enter and just let it do its installation. Objection is the client program that needs Frida client to run. So during this process, it will also install automatically the Frida client. Note that this installation is happening on the Windows PC, not inside the Android emulator. Earlier on, we already installed the Frida server on the Android emulator. So now we are installing Objection and Frida client, which will be running on the PC. And they will be communicating with the Frida server on the Android emulator. So now you can see it is successfully installed, completed installation. We will now open a command terminal to test. So just type Frida and enter, and you can see it managed to detect Frida. Now you type Objection, press enter, and it also detected Objection. So this proves that you have successfully installed Frida and Objection. So that's all for this video. Thank you for watching. Hello, welcome back. Now we are going to test our Objection and Frida client. So make sure your LD player is first running, and we have to upload an APK file to the emulator first. So go and download this APK file from the resource section, hello-apk, hello app apk. Drag and drop onto the LD player to install it. Now double click to test it, and this is a simple app that I've written just for purposes of testing the objection and the Frida client. So simple app, doesn't do anything, just displays some user interface. So we are going to hook this app from Frida and also from the objection. So in order to attach to this app, we open the command prompt first. We open the command prompt. We type Frida-ps space dash capital U lowercase AI in order to list the processes which are running on the emulator. And you can see Hello App is running. The normal name is Hello App and the package name is com-example.helloapp. What we need is the normal name, the common name, Hello App. Frida will use this to attach to the process. So you type Frida space dash capital U dash N and then quotes Hello App. Hit enter and you can see it has successfully connected. It has successfully attached to the Hello App. Now we can exit it by typing exit. Next we are going to test objection. So we type objection. Before that we release again by typing Frida-ps-uai to see the name of the package. So the name of the package for our Hello App is at the bottom here, Hello App. The name of the package is com.example.helloapp. So this is the package name you want. Right click on it to copy it. Select it first, right click to copy it, and then type objection dash gadget, then paste, right click to paste the package name and type explore at the end. Hit enter and now it will connect and you see it says agent injected and response. So it is working, and after a while you should get some more information, and there you go. So you can see our objection is also working. It managed to inject itself into the process, our Hello App process. So it is doing this through the objection, through the Frida server. So now we can exit, and so that's all for this video. Thank you for watching. Hello and welcome back. We also need to install Android Studio, so go to this link here and click on it. The reason why we need this is because we need the build tools. So click on the download Android Studio button. And scroll down. Click the checkbox to agree and click on the button to download. So let it complete the download. Open the download location and double click on the installer to begin the installation process. Click next, and you don't need Android virtual device. You can uncheck that if you don't want. You already have LD player. Take note of the location where Android Studio will be installed. Click next, and here click install. Then click on next again, and then click on finish, and it will launch Android Studio for the first time. The default is do not import settings. Click OK. Here click don't send. Click next. Here leave it at the standard default. Click next again. Here you can change to a lighter theme, so I prefer light. Click next. These are all the modules that will be installed. Take note of the location: C, users, app data, local, Android SDK. That is what we want, the Android SDK. Click next. Here you have to agree to the license. Click accept. Click next, but you won't be able to click next because there are additional license you need to click on to agree. Click on this additional license. Click accept. Click on additional license. Click accept. Then once everything is accepted, click finish. So this is to confirm everything is downloaded and installed. Click finish. And this is the welcome screen. So now we can find, we already have the platform tools from the earlier installation. Now we're going to look for the build tools. So search for percentage app data percentage, click enter. You go to app data roaming, click on app data, click on local, click on Android, click on SDK, click on build tools. This is the one we want, build tools. So select version 30, and then over here you can see we have APT, APK signer, and all the other tools which we will be using. Copy this path. We are going to create an environment variable. So search for edit system environment variables, click on it, click on environment variables, click on path, click on edit, click on new, and then paste the path that you have copied, hit enter, and then click on move up to the top, put it right at the top. Below it should be platform tools. So now click OK, click OK again. So this is how you install build tools. Thank you for watching. The next tool we need to install is APK tool. So go to this link here, this website, and read the instructions. You need Java. So check to see if your Java is available from the command line. Just type the command java dash version, hit enter. So if it's not detected, that means you need to add it to the path environment variables. So this is the location where Android Studio installs Java. So go to this location, copy the path, then copy this path, and then edit the system environment variables, click on the path, click edit, click new, paste the path, hit enter, and then move it all the way to the top. Then click OK, OK again, and OK one more time. We need to close this and reopen the command prompt so that it will read the new environment variables. and now we type Java dash version, hit enter, and now you can find it. So this satisfies the requirement that Java needs to be available from the command line. Let's see what's next. Next, we need to download the wrapper script. So right click on wrapper script and save as, and save it to your downloads folder. It's a batch file, apk2.bat, and then download the latest apk2 here. Save link as, and also download it to your downloads folder. Then we have to rename it to apk2.jar. So let's wait for it to finish downloading first. The reason why we need to use apk2 batch file is so that we can run it from the command line without needing to type a long command. So now let's rename it to apk2.jar. Let's see the next instruction. So wrapper scripts are not needed, but helpful if you don't want to type java-jar apk2jar over and over. That's why we're using the wrapper script. Move both files to Windows directory. But if you don't want to put it there, you can also put it in our platform tools location. So let's cut it first. Select both file and cut. You can either put it here in the Windows directory so that it's visible everywhere, or we can put it in an existing folder which is already in the environment path. For example, inside the platform tools. So I'll put it here. I'll paste it in here. So next thing to do is to test it. Try running apk2 from the command prompt. So let's open a new command prompt and type apk2, enter. So we have successfully installed it, as you can see. So this is how we install apk2. Thank you for watching. Welcome back. Now I'm going to show you how to patch the apk file using this command. You patch using objection. Why you want to patch? So that we can inject the Frida server into the target apk. These are the valid architectures we have to specify in order to patch. So this is the directory containing the target apk that we are going to inject Frida server. The reason why we need to inject is because the device is non-rooted. Therefore, we have to inject it. We can't install our Frida server inside. So we use this command now, adb shell get proc our product CPU ABI, to find out the architecture of our device. I'm going to use a physical device. I will connect my Android phone using USB cable, and this is my Android phone here, mirroring here. And now I will connect to it using the adb shell command, followed by get proc. So I type adb devices to list, and then here this is my physical device. I will now type ADB shell to connect to my device, and immediately I get a non-root shell. If I try to SU, I find I cannot become root. ID also shows that I am not a root. Who am I command also shows that I am not a root. I will now type the get prop ro product.cpu.abi command to get the architecture, and I find that it is ARM64-V8A, which is this one here. So we need this information for the next step, which is to run this command. So now I'll exit, disconnect to my Android device, clear screen. Then I'll type my command, objection patch apk -- source, and I'll type in my package name for my target apk file. Type -a architecture ARM64-V8A. Hit enter. So that is the architecture that we discovered. So now it will perform the patch to inject the Frida server, also known as gadget, into the target APK file and rebuild it. So the process involves unpacking the APK file first, and then injecting the necessary permissions and writing a new Android manifest, and then to load the library, and then to copy the Frida gadget to the library path and try to rebuild the APK gadget. Try to rebuild the APK with the gadget. So now you will see there is some error in red. So something went wrong. So we will need to delete the patch file that was created and try to do it again with a different option. So this is the patch file. So we delete it first. And now we will clear the screen and we'll try with a different option. We'll put -- and at the back we will add additional parameters. So if you get error, you should add these additional parameters at the back, which is -- use -aapt2, and then hit enter. So let it try to do the patching one more time, this time with a different tool. Finally, we succeeded. So this is how we can patch APK target file to inject a Frida server inside it. We only use this technique for non-rooted devices. Thank you for watching. Hello, welcome back. In this video, I will show you how to enable developer mode in your Android physical device. So this is a mirroring of my real physical Android phone. So you go to settings and then go to the about phone, click on about phone, and then scroll down and look for software information and click on it. And then look for the build number and clicking on it multiple times until you see the message at the bottom appearing saying that developer mode has been enabled. It will appear at the bottom. So you might need to click several times on the build number. So once developer mode has been enabled, you can go back to the settings, go back to the main menu of the settings, and then just below the about phone you will see a new menu item called developer options. So you can click on it now, and then you can scroll down and turn on USB debugging. Once you turn this on, you will be able to connect this mobile device to your computer using a USB cable and then debug it with the ADB commands. So this is how you can turn on developer mode for your Android phone. Thank you for watching. Hello, I'm going to show you how to install your bash APK file to your Android device, the non-rooted Android device, and then to test it to make sure it is running. So in the one of the previous lessons, we've already built our Android bash APK file, which is this file here, with the name objection in the name. So now we are going to install it. So I've already connected my Android device, the non-rooted Android device, to my laptop using the USB cable, and as you can see, the APK file has not been installed yet. So first thing I will need to do is to confirm I'm in the right directory, so that contains the objection patched file, and I do a ADB device to list the devices connected to my laptop, and I can see it there. It is already connected. Confirm. So now I can install it by typing the ADB command followed by the install option and followed by the name of the APK file that I want to install. If there was only one connected device, I can just press enter now. However, if I have multiple devices, more than one, then I have to specify which device I want to install it to by using the -S option. And then copy the name of the device ID, selecting it, right-clicking the copy, and then pasting it down here. Now I can press enter to start the installation process. So the installation is successful. As you can see, the new icon has appeared there, Hello App. I can now launch it, and it will be launched in a suspended state. That is why it appears white. It is waiting for the client to connect. The Frida gadget has started its Frida server, so now we are going to list it using Frida ps-uai command to confirm that the gadget is running. The gadget contains the Frida server. As you can see, the name of the Frida server is called gadget. So now we can connect to it using the command frida-u-n followed by the name of the gadget and hit enter. So once it's connected, the app will come out of the suspended state and run in full. And now you can see you have a command line where you can perform your analysis. So now I'm going to summarize the steps for non-Android rooted phone. For non-rooted Android phone, you should patch your objection first. You need to patch the APK file with the correct architecture of the gadget. So these are available gadget architectures, and you can get the architecture by using these commands, adb shell followed by getprop. So for example, if you have this architecture, you can supply that in this command, in this option. If you get an error, then you should use the -aapt option, -aapt2 option. You can read about this here, the errors. And then once you got the APK file, patch 1, you can install it on the non-rooted device. First thing you do is to list the devices, ADB device. Then you will see the ID there. Then you use the adb-s to select the device and install the patch APK file, which is this file. This patch APK file will have a gadget inside containing the Frida server. So after you have installed it, you need to run it. It will enter in a pause state. Then you can list out the running processes using this command and get the gadget name. By default, the name is gadget. And then you can connect to the gadget. So the gadget is the Frida server. So after connection, you should get a command line like this where you can perform any analysis commands that you want. For now, we're just going to type the exit command. So this is how you can install your patch APK file containing the gadget into a non-rooted Android device, and also how to test to make sure that it is correctly installed and correctly working. That's all for this video. Thank you for watching. Hello. In this video, I will show you how to use the APK tool to reverse engineer this APK file and then make some changes and then rebuild it. So let's get started. So open a command line terminal, search for cmd command, and then copy this path to this hello app APK file and change directory to it by right clicking and pasting the path. Hit enter. Type the dir command just to confirm that the target APK file is there. So in order to disassemble, we need to use the APK tool. So the command to disassemble is you type the name of the tool, APK tool, and then D for disassemble, and then followed by the name of the APK file that you want to disassemble. Just hit enter. And now it has finished the disassembly. So you take a look, there will be a new folder, hello app. So this one contains the disassemble code. You can take a look at the smally is a file containing the smally code. So you open smally.com example. So this name of the folder is a JavaScript convention. It follows the package name in reverse, com.example.helloapp. So inside here you will find all the disassemble code in smally format. Smally is a kind of language for disassembly for Android device. So you can think of it as some kind of assembly language for Android devices. So if you open it, you can take a look at what it looks like. For example, if you right click on this and open it with a text editor, I'm going to use Visual Studio. I will be able to see what it looks like. It looks like this here. So at the moment we are not going to do anything about this, just to tell you that this is what the disassemble code looks like. Okay, let's close it. Now the next thing is we analyze this further. We go back to the hello app here and look at the manifest. Right click and open it. And you can see this is the manifest. So we can add some extra permissions to it. For example, if you wanted to modify this application. So an example code that you can add, for example, if you want to add the permissions for internet, you just open one line here and then you can paste it here, the permissions. So now you added the internet permission to this application. So just save it and close it. So now we want to rebuild it using the APK tool. So let's go back to, so after rebuilding there will be a new folder containing the rebuild APK tool, containing the rebuild APK. So in order to rebuild it, we go back to our command line terminal. Let's clear the screen, and the command to rebuild is apk2 build, B for build, hello -app, and then hit enter. So the name of this should be the name of the folder containing your code that you want to rebuild. So this is the syntax for it, and hit enter. So you can see there's an error here, invalid resource name navigation. So this means that you need to use another option when you are building. So the option is like this. Let me show you. You need to add this option use -aapt2. By default it uses aapt1, but now the latest Android applications uses aapt2, so we're going to add that as well as an option. And then you repeat the build command, press enter, and it's successfully built. No errors. So where do you find the new APK? Go back to your parent folder, hello app. Inside it there will be a new subfolder called dist, short for distribution. So just open it and you'll find your hello app there. So now, in order to confirm that the Android manifest has been modified with the internet permission, we are going to disassemble this. So let's navigate to this directory, just copy the path and cd to paste the folder, and dir to confirm that we're in the correct directory. So we're now going to disassemble this. So just repeat the other command. You just press the up arrow key to go back to a previous command list, and this is the one we want to use, apk D for disassemble, and then the name of the apk file, which is this one. So we press enter, and you should now be able to see a new folder which contains the disassemble code. So let's open this and let us check the apk file. Let us check the manifest file here by right clicking and open it with any text editor, and then you will see that the new permission is there. So this confirms that we have successfully disassembled our original apk file, modified it by adding an additional permission, and then rebuilding it again using apk2. So that's all for this video. Thank you for watching. Hello, welcome back. In this video, I will show you how to install Dex2Jar and also JD GUI. So the first one is this link here. So head over to Dex2Jar, and then on the right you will see the releases button. And then we scroll down and click on this to download dex2jar.zip. After it has finished downloading, open the downloads folder. You will find the zip file. Just cut it and put it in the location of your choosing, and then just unzip it. Inside you will find the Dex tools. So in here you will find all the Dex tools. The one we are interested in is D2J Dex2Jar batch file. Copy this. We are going to create a new path environment variable. So just copy this path and then open your command line tools. So we need to create a new path to this location. Just copy this and we're going to add this to the environment variable. So just copy this and then open your environment variable, search for environment variable, select path, edit, select new, paste, hit enter and move it up. And then click OK. So now you can run it from anywhere in the file system. Just test it out with your command prompt. D2J dex2jar. If you forgot the name, you can always go back to the location where you install it, which is over here. The name of the executable batch is D2J dash dex2jar. D2J dash dex2jar. So just hit enter, and if you see this, that means you have correctly installed it. The next tool we're going to install is your JDGUI. So head over to this link here, and then scroll down and download this file. Click on it to download. So once it's finished downloading, open the downloads folder, just cut it and then put it in the location of your choosing. So you can paste it here if you like, or let us put it in the platform too, so that we don't have to create another additional environment variable. So you have your JDGUI here. So just put it in your tools folder over here. So now if you want to run this tool, you can go to the command line, navigate to this location. Let's copy the path, CD, right click to paste, dir to check that we have the tool there. So to run a jar file, you type java -jar followed by the name of the jar file, then hit enter, and this is what it looks like. It's a graphical user interface tool. So this confirms that you have successfully installed your JDGUI. So in this video, I've showed you how to download and install dex2jar and also JDGUI, and also how to test them to make sure your installation is successful. So that's all for this video. Thank you for watching. Hello and welcome back. In this video, I'm going to show you how to use dex2jar and JDGUI. So the first thing we need to do is to use dex2jar to decompile this hello APK and then convert it into jar file. And then once we got the jar file, we can decompile it using JDGUI. So let's get started. We open a command prompt. So we go to search, and then we will navigate to this location. And then inside it, this is the target, hello app.apk. So to use it, we type d2j dash dex2jar and then the APK file that we want to convert. So we hit enter, and then it will convert into jar file. Okay, it has completed. Now you will see there is a new file called the hello app desk2jar.jar. So this is the one that we want. So now we are going to open this with JDGUI to decompile it. So let's run JDGUI. So let's see, where is JDGUI? JDGUI is here. So we change to this location. Then we type java -jar JDGUI. Now we can open our jar file. Click on this and go to the jar file. This one. So just open this jar file which you have already created using desk2jar, and you can see it has decompiled it. Click on this and you can see this is your package. Inside here is your classes. Click on it and you can see the source code. So this is how easy it is to decompile a jar class. So it is a two-step process. The first step is it's a two-step process. Step 1 is to use the desk2jar to convert your APK file into a jar file. Once you got a jar file, you will use java -jar JDGUI to open the JDGUI, and then once it's open, you open the jar file that you got from the desk2jar. So that's all for this video. Thank you for watching. Hello and welcome back. In this video, I'm going to teach you about the command line interface for Frida. So go and download these notes from the resource section for this lecture. Understanding Frida Command Line Interface, CLI. So this is the basis for scripting in Frida. We must first understand how the command line interface works, and then from there we'll have a basic understanding. We will be able to make sense of scripting later. All the scripting instructions are coming from these basic command line interface commands. So as you can see from these lecture notes, there is a reference here. So if you open this reference, you will come to this web page over here, where you can see some of the Java commands that you can execute from Frida. So let's try and see how this works. As you can see, I have now opened LD player, and inside it I have the hello app. If I click this, I will run the hello app. So now, before you do any kind of tracing with Frida, you must first make sure that you can access it from the ADB command. So open the command prompt here, and the first command that we are going to type is ADB devices. So go ahead and type ADB devices, and you can see emulator 5554 is there. It is referring to your LD player. And then the next thing you want to make sure is Frida server is running on the emulator. So to do that, you have to open a shell and run this command ps pipe grep Frida server. So let's try that now. First, you open a shell by typing adb shell. So when you type adb shell, it will connect to the emulator. Adb shell, and then immediately you get a root shell, as you can see. Now you need to check whether your Frida server is running. This was a server we copied and uploaded to our LD player some lessons ago. So to find out whether it is running, we type this command called ps, which means process. That means you want to list all the processes. If you just type ps enter, it will list a long list of process. But what you're interested in is a Frida server. So as you can see here, the last column is the name of the process that is running. You can actually scroll down and look for Frida server. But there is an easier way. The easier way is to pipe the output for the ps command. This is called the pipe symbol. So what you need to do is repeat the same command, the ps command. Let's clear the screen first. You type ps command, but instead of pressing enter, you redirect the output to the search command. So grep is the search command. So what is it searching for? What you want to search is this string called Frida server. That is what you want to search. So it will filter out from the result of your process any string containing the string Frida server. Hit enter. So you can see Frida server is already running. Sometimes Frida server may not be running. So if Frida server is not running, then you will need to start the Frida server. So supposing the Frida server is not running, the way you start it is to type data, the path to the Frida server file that you copied earlier on, and then enter, and then /, the name of the Frida server file, and then put an ampersand at the back to make it run in the background, and then you hit enter. That's it. So after you hit enter, Frida server will be running. So once it's running, you need to close this command prompt and reopen a new command prompt. Open the new command prompt like this, and then you are good to go. That's it. So the next thing you want to do is to list the packages, the processes which are the programs which are available on the server, on the emulator. So to do that, you type the Frida-ps command -uai and you hit enter. Then it will list all the packages that are there on the LD Player emulator. And this one, hello app, is referring to is referred by this line here. So there are two. The important column is the name column, which gives the common name hello app, and the identifier, which is the column containing the name of the full package, com_example.hello app. So you have to remember these two whenever you want to make commands later on. So we'll make use of this com_example.hello app in the next instruction, which is this instruction. So this instruction is where you will start the Frida app, and also you will hook the Frida app. So this is what you do. You type Frida-u-app, then the name. You don't have to type the name, you can just copy from here. Just copy it from here. Highlight the package name, right click to copy, come down here, right click to paste. That's it. So once you press enter, it will attach to hello app. There you go. You are attached to it. As you can see, com_example.hello app. And then once it's attached, it will run the app, and then it will pause. So now the app is in a pause state, waiting for you to do something. So there's a hint here, says use %resume. So this is a command. So when you type this command, the app will continue running. It will exit the pause state and continue running. So that is what we're going to do next. We are going to type this command. So just type %resume, hit enter, and you can see now it has run. It has exited the pause state and it is now running. So now this is called the REPL loop, the read, evaluate, print loop. So whatever command you type here, it will evaluate and print the result, and then it repeats again. You type the next command, it will read, evaluate, execute, print, and print the command, print the result out. So this is the power of Frida CLI. So some of the commands that you can run are listed in this reference which I shared with you earlier, this reference here. you can type any of these commands in the command line. So this is called the Frida shell down here. So in the Frida shell here, you can type any of these commands. So let's say we run this command java.available. So this method is to test whether or not the current process has a Java virtual machine. So notice what happens when I type Java, I put a dot. So this class Java has got all these available methods, and you can scroll down and see which one you want. The one that we want is available. So you can either look for it by using the arrow key to go up and down, and once you find that what you want, it will be listed here. You just hit enter, then it will execute that method, and then you will find the result true. So when you see true here, it means that the Java virtual machine is available. So you see here a boolean specifying whether the current process has a Java VM loaded. So you see here true, that means yes, Java is available. Another command you can try is java.android version. So let's try that now. You type Java again, put a dot, and then Android version. When you type AN, it comes up the useful suggestions here, and you can see the one that you want is the second one. So you just use your arrow down button, go down there, and it will be listed. Then you press enter, and it will show you the version, which is version 7.12 for the emulator. So this is a quick example of what the CLI for the Frida looks like. It looks like this. Okay, so most of the time we will not be using this CLI, but we'll be using the scripts. We'll be making use of these instructions like this in a script form. The script will run much faster and more efficiently than the Java CLI, than the Frida CLI. So this is all I want to introduce you in this lesson. What is the meaning of Java, meaning of Frida CLI? So that's all for this lesson. Thank you for watching. Hello and welcome back. In this video, we are going to do our first Frida script by writing a hello world script. So the starting point for this video is for you to go and download these notes from the resource section for this lecture. So these notes contain all the steps that we will take to do the practical. So let's get started. The reference is this link here, which is referring to the documentation for Frida scripting, and this is the page, and we have seen this from an earlier lesson. What is important is to scroll down and look at an example of a Java script, a Frida script. So every Frida script will contain this class Java and this method perform, and then whatever you want to perform will be defined in your function, which is here. So we are going to write this now. You can use any text editor you prefer. For me, I like to use Visual Studio Code. So if you want to use Visual Studio Code, you can also go and download and install it. So just search for Visual Studio Code download. So I'll create a new file now, and then I will save it as a JavaScript file. I will save it in this location, Frida Android Projects, Frida Scripts. So I'll just put it in here. I give a name, Hello World, and save it. So now I'm going to start coding, and we are going to base on the template that is given by the documentation. So the first thing we type is java.perform, and then semicolon. So perform is a function which comes from the Java class, and inside you can type any function you want of your own choosing. So according to the documentation, it is using this syntax called arrow function. You can either use the same syntax or you can use the old syntax, which looks like this. They are the same. Either one is fine. So you can define your own function here, and then within this function here, you can expand and just write console.log, and then here whatever things you want to print out to the screen. Alright. Alternatively, you can also use the new syntax for Java, which is called arrow function, like this. So you can, for example, you can type and then opening, closing curly brace for the function definition. So this one replaces the function keyword, and this arrow here comes together with this new syntax. So inside here, you can expand the curly brace and type the function that you want to execute. So in this case, console.log, and then I'm going to print hello world, like that, semicolon. So now you can save it. When you see there's a circle here, it means that some changes has not been saved. So you just click File Save. So now we are going to start our emulator. So I'm going to run my LD Player emulator. And basically I'm just following the steps here. First thing is to open after the emulator has launched, you will open the ADB devices command. I'm going to rotate the screen. So now I'm going to open the command prompt, and then I will navigate to my folder, which is containing the script. So the folder is this folder that I created the script in just now. So this is the Frida script that I'm going to run, hello world.js. So before we can run the Frida scripts, we need to make sure that the Frida server is running. So as usual, I will type ADB devices to check that the device is attached to my ADB, and I can see emulator is there, and then I will do ADB shell, and then I will ps and grep Frida and see if it's running. So if it's not running, I have to start it. And I will run the Frida server now, and I ps again, and I check the Frida server is running. So now I can close this command prompt and reopen a new one, and go back to my Frida script. Now I'm ready to enumerate the Frida. So I just run this command, and this is my target application. So I'm going to now use it, and then I copy this target application, paste it here. And now this differs from a previous lesson. Previously we just press enter to launch the application in a suspended state, but this time we want to load. So we must put L, we want to load the script, and we need to specify the script that we want to load. So -L here is to load our script hello world. So now let's press enter and see what happens when you press enter. So now your hello app is started in a suspended state, and we have to type this resume to let it continue. So we type %, followed by the resume command, and you can see hello world here. So this hello world is coming from this line, console log. So how it works is that when you run the Frida-u-f and with the -l parameter, what it is saying is to launch, is telling the Frida server to launch this package, this app, in a suspended state, and then load this hello script and execute it. So this hello script will be injected into your hello app, into the hello app process memory. So once it's injected into the process memory for your hello app, it will then execute the script inside the memory. So the first thing it does is java.perform, and java.perform will then call the function inside it. In this case, we have this anonymous function, and then here, inside it you have one instruction, console.log hello world. So that's why you're seeing hello world here. Okay, so now you can go ahead and try to change the message, and this one also should update accordingly. So maybe you want to put buy and save it here, and then here you can see hello world buy immediately updates. So this is a loop, actually, the REPL loop, which I've explained to you in some earlier lesson, the read, evaluate, print loop. So whatever changes you make will be executed inside your Frida injected script, So hope this helps you out to understand now how you can write your own script. And our first script is hello world script. If you wanted to quit this, all you have to do is Ctrl D or Ctrl C, and then it will quit everything. Alright, so that's all for this video. Thank you for watching. Hello and welcome back. In this video, I'm going to show you how to write a script, a Frida script that can list down all the classes which are loaded by the Hello App application. So if you refer back to this documentation which we have seen before, we can see that over here there is a method called enumerate loaded classes, and there's also callbacks, and the callback here are objects. So the callback here is an object containing these functions. So let's see how we can do this. I've already got my Visual Studio Code open. We are going to create a new Frida script, new file, and we are going to save it as list classes.js. Click on save, and this is the location where I'll save it to, Frida scripts. And so I click on save, and then in here, as usual, we put the function java perform, which we have seen before in the previous lesson. And then inside the java perform, we are going to define our function that we want to perform. And then inside this function, this is where we put all the things that we want to do. So in this case, we want to enumerate the classes using this function enumerate loaded classes. So you can just copy this and paste it in here. So now what we need to do now is to write the object for the callback. According to the documentation, this callbacks is an object. So in JavaScript, we can create objects using the curly braces like this. So in JavaScript, this is an object, and then inside the object we can put key value pairs. For example, key 1 has got the value 1 and then comma, and then key 2 has got the value 2 and comma. So this is the structure of a Java object. So in this case here, every key is separated by the value using a colon, and then every key value pair is separated by each other using a comma at the back. So you can put as many key value pairs as you want. So this is how JavaScript objects are created. So in this case here, we can see from the documentation that this callback object contains all these on match and so on. So the two that we are interested in is on match and on complete. So we can define the on match and on complete function inside here. So for the key one, we will call it on match, and then the value for that on match is going to be a function. So we just type the function keyword here and then open close curly brace. So this is just a blank function now, but the signature for the function for on match has got two parameters, name and handle. So we put it in here, name comma handle, and then the second key is key 2. So key 2, we are going to put the label on complete, on complete, and then the value 2 for on complete, we have to define its function as like this. Same way, function always has got this syntax in JavaScript, and that's it. So this is how we implement this Java enumerate loaded classes in JavaScript. So now we can do whatever we want inside here. Here we can put something, and here we can put something, whatever you want to do. So in this case here, we just want to print out the name. So we can type console.log followed by the name, like that. And then for this on complete, we just want to give a message saying that we have completed the enumeration of the classes. So we can just give a useful message saying completed or just done, like that. So we can save this now and test it out. So open the command prompt and then navigate to your scripts folder, dir to confirm that your list classes JS script is there. And then as usual, you will have to make sure that your Frida server is running. So you have to do an adb devices, adb shell, and then ps grep Frida server, and see if it's running. So it is running because I did not close the server, I did not close the LD player from the last session. But if you find that it is not running, and you should know how to do it, you should know how to start it. So I won't go into that now. So it is running. We can exit in the shell, and now we want to hook the application hello app. So to know the package name for hello app, let me clear the screen first. We can use the Frida ps command -uai, and you can see the package name is com example hello app. So I'm just going to copy that and then going to attach to it, and we're going to paste the package name here, and then we're going to load our list classes JS file here. Now hit enter, and it should start the hello app in a suspended state, and it has started now in a suspended state. and over here it should ask us to hit the resume button, the resume command. Okay, let's try that again. The list classes fail to load for some reason. Okay, I found a mistake. It is actually this missing curly brace. Here is one, and there should be one here. Alright, and here you can put a semicolon, that's fine. Alright, so now it's correct, and you can download this from my resource section for this lesson if you can't get it to work. Okay, so now you can repeat the command, it should work. Alright, so now you can see it is loaded in a suspended state, and we can resume it. Hit enter, and you can see it lists all the classes that are loaded by this APK file, and it is a long list. Alright, and when it is finished loading all the classes, it is going to show the done message, because the done message is coming from here. Alright, so now my question to you, how do we limit the output here to show only those classes which are having the package name for this APK? So I'll give you a tip. You can use this function, JavaScript includes. So we get the name here, and then we type .includes and put the package name here. Alright, so I want you to try this on your own first. Just pause the video and give it a try, and then later on you unpause it and see the solution. So go ahead. Alright, I hope you given it a try. So what you need to do is put an if statement here, if, and then define a new function here like this. Cut this and put it inside this if function. So inside this if function, we are going to test whether the name includes the package name. So the package name is hello, I think it's com example hello app, and it has to be in strings because this is a string, like that. So if this on match here, this name contains this string, then only you print out, otherwise you don't want to print out. That will reduce the output here. If you forgot the package name, no worries, you can actually go to a command prompt and then do a Frida ps, and you should get the package name here, com example.hello app. So let's remove the space, Ctrl S, and notice it will run again, and this time it shows only those lines containing this string, com example hello app. You see that? Alright, so let's see what happens if we Ctrl D, clear screen, and rerun it. Alright, so now it's going to start the app again and pause it, and we are going to resume. And you notice it just prints done without printing out the classes containing this string. So how do we make it rerun again? There are two ways you can do it. One way is to come here and Ctrl S to resave this, Ctrl S to resave, and hit enter here, and you see it prints the done here. Another way is you can come over here and then click the command reload, like that. So these are two ways you can cause it to rerun the script. Okay, and the last thing I want to mention is how do we save these results out to a separate file. So you can do it by opening two consoles. Let me show you. So we can exit this now, clear screen. In this first console, let's open it separate. In this first console, we are going to run this command, and then we are going to redirect it out to a file, maybe list of classes. And then over here we have to change this to n. So n takes a name rather than a package. So in this case here, we have to change this into a to the name of the app. So the name of the app is, I think, Hello App. Okay, so if you're not sure, you can go back here and search, do another Frida listing, and this should give you the name Hello App. Alright, so -n accepts Hello App, -f accepts the package name. So that's the difference. Here we want to put -n because we want to redirect the thing to another text file. That's why we need to put -n. We cannot put -f. If we put -f, then it will run the program and pause it. Okay, so now we have to open another shell. Don't hit enter yet. Open another shell, and over here we can type Frida -u -f, and here we can actually paste the name of the package. We don't have to load the script, we just let it pause. Okay, so now we hit enter here, and so this thing will reload and it will pause. So we're going to resume this, and once it's resumed, over here we come and hit enter. Alright, and now we can go to this location and look for this text file. So we can go there and open the text file. So if you come here, you will see a text file, list of classes text, and if you open it, you will see this. See that? So this is how you can redirect the output to a separate file for further analysis if you wanted to. Alright, another thing I want to tell you is how do we not pause the Frida program when it is running. Okay, let's go to location of our script file. Make sure our script is there. Okay, so let's run our script now. Clear the screen. Let's load our script. Now if we don't want the script to pause, we can type no pause here. So if we did this, then it will not ask us to type resume. Okay, let's try it. See that? Straight away it went on to load the whole process without going into a suspended state. Okay, so now over here we want it to run the script. We just press enter again one more time and then type the reload command, and see that, so it reload the script, and now it ran the script and shows us the output. Okay, so let me explain a bit about the script, how it works here. So over here, when it runs, it's going to fetch all the name of the classes which are loaded by the APK file, and then in here it's going to compare, it's going to check whether that name contains this package name. If it does contain this string, then only it will print out. That's why we are seeing only those classes which has got the package name hello, com example hello app. And we can see here there are 1, 2, 3, 4, 6 classes that are loaded: fragment, main activity, activity main, and so on. Alright, so that's how we can play with our scripts. It's quite flexible in what it can do. So I think that's all for this video. Thank you for watching. Hello and welcome back. In this lesson, we are going to use another method called Java use in order to list the methods and properties of a class. So this is the reference to this method, java.use. So I'm going to start a new script here using my Visual Studio Code. File new, and I'm going to save the file. In this case, I will call it list method and properties. List methods and properties .js. Save, and I'm saving it in the Frida scripts folder. Then I will start my Java function called Java perform, remembering to put a semicolon at the back of the function. Inside it, I will define my anonymous function, just like before, and within the curly braces I will put the instructions that I want to call. So for now, I just want to console log a message just to say OK, just to make sure that I'm able to hook my target APK. So I'm going to save this now, and I'm going to navigate to this folder where the script is being stored. So now I'm in my folder Frida scripts. I will run the directory command to see what is inside, and this is the script that I'm going to make use, list methods and properties.js. I have got my LD player running, and my target APK file is hello app. So I'm going to hook this target APK file using the script. I'm going to inject this script into this target APK file. So I'm going to call the Frida-ps-uai to list all the apps inside this LD player. And this is my target package, com example hello app. Now note here that before I did all this, I already ensured that my Frida server is running in the LD player. So now I can copy this package name, clear the screen, and then hook the app using Frida. And then I paste my package name and I put the -L to load my script, which is list methods and properties JS. And at the back, I will specify no pause so that it will not wait for me to enter the resume command. Instead, it will just go ahead and run the app, and it will not enter a pause state. So now I hit enter here. And the Hello app has been launched, and it did not enter any pause state. Instead, it launched fully. And over here, you can see the OK message showing up, confirming that there is no error in my script, because this OK message is coming from this console log. Now I'm going to make use of this Java use function. So I just copy this into my script here. Below the OK, I will just say Java use, and then making sure to put a semicolon at the back. Inside here, I have to specify the package name, rather the activity or the class name that I want to target. So how do I know the class name? Now, in order to know the class name, I will have to know the activities or the class. To do that, I can go into my emulator and run my previous command. My previous command is to list the classes, yes? So I can do that now. And here, I list my classes. I call the list classes script. And I hit enter. I got a typo there. It should be list classes. Now I hit enter. And then I hit enter again. And I reload. Okay, now over here, I have got the name of the class I want to target. Let's say I want to target this one, main activity. So I just copy this. Right click, copy. I come back to my script, and inside here, within the double quotes, I will right click and paste. So this is the class that I want to target. So I use Java use to do that. After that, I will have to save it to a variable. So I'm just going to call it activity class, like that. So you can refer to this reference here. If you scroll down, you can see over here Java use, specify the activity or the class that you want to target, and then you need to save it to an activity. You can use constant, so you can use var, it's up to you. So we're just going to put constant based on this recommendation here, because this this activity class is not going to be modified. So it makes sense to define it as a constant variable. So now we got that over here. We got that. We can now test and see what happens when we console log it. Console log dot log activity class. Then we save it. So down here, we are coming back to our this terminal. We exit this one, clear screen. Now we are going to relaunch our previous command, our previous script, list methods and properties, which is this script. Okay, now we hit enter. Alright, so it sees here, it has listed com example hello app.main activity. That means there is no error. It managed to print out the name of the activity class over here, as you can see. Right, so now our next objective is to get all the methods and properties that is inside this main activity. Now to do that, we can make use of a JavaScript function called get own property names. So object dot get own property names. Now you can refer to this online references by pasting it in Google, and you can see here there are some references in developer Mozilla. So this is how you can get all the property of an object by using the static class object, by using the object class and calling the static method get own property names, like that. And then it will return an array. The return is an array. So let's try that now. So what we're going to do is to console log the get property name. Now get property names need to have parameters. As you can see from the sample here, you need to specify the object. So over here, our object is this activity class. So we open and close bracket here and type in the activity class. Then we save it. And then we see what happens to the output when we save it. So let's Ctrl S to save it. And you will see it prints out an array. So this is an array of all the methods and properties that come from this main activity class. Now we want to see this in a nicely formatted view, so we can use the JavaScript method called join. So you can search for that JavaScript array join, and you can see here the join method by referring to this, right? So array join will then reformat the array in a readable method. So this is the syntax for join. You can specify what is the join string that you want to use to join all these elements into a string. So for example, you click on try yourself. Let's say you have an object, an array called fruits, and then you call fruits join, and you specify the string n, and the output will be banana and orange and apple and mango. and here. So if you wanted this to be nicely formatted, each element in one line, then over here you just have to specify a new line character like this, backslash new line character, and then when you run it now, it's going to specify everyone in a new line character, backslash r maybe, carriage return 9 feet. Let's try it again. Alright, because this one is HTML, so that's why this one doesn't return new line. But we can try it in our Visual Studio Code and see what happens. So at the back here, we also put join, and we specify a new line character. And now we take a look at this, see what happens when we Ctrl S to save it. See that? So now we have every element of the array printed on its own individual line. And then because of the new line, after printing each element of the array, it goes to a new line. So this is how we can write a script to list all the methods and properties of a class. So some of these are methods, like getDelegate is a method, and some of it may be properties, like for example delegate tag is a property. So a property is like a variable, but a method is a function, so that's the difference. But using this getOwnProperty names, it doesn't differentiate between methods and properties, it prints everything. So this is how we can write a script to query and list out all the methods and properties of any class that we want. So go ahead and try to experiment on your own and try to choose another different activity in class and list out all the methods and properties inside that class. So try that as an exercise. So that's all for this video. Thank you for watching. Hello and welcome back. In this new section, we are going to learn how to hook functions using Frida and also how to bypass root detection. So first of all, we will understand how to use Frida to hook functions, and in Java, functions are also known as methods, so we can use these terms interchangeably. We will learn how to modify the function's return values, and then we'll also understand what is root detection. Root detection is where app, when it runs, it can detect that it is running inside a rooted device and therefore it will quit. This is some of the security mechanisms built into the APK file to resist reverse engineering. So one of the basic features of security for Android is to detect whether the device is rooted, and if it's rooted, it will refuse to run. That is the meaning of root detection. So we can actually find out the function that is detecting the root and then use Frida to hook that function and then bypass root detection by modifying that function's return values. That is the idea and the method of how you can bypass root detection. So in order to study this, go and download the APK file which I provided for you. Now in order to study, we are going to need an APK file. So this is where I selected the APK file for our next project, the OWASP website. So what I did was I came here, click on Crack Me's, click on Android, and then click on level 1 and click on the uncrackable level 1 APK and then click on download. So you can download this. I provided this APK file for you to download in the resource section. After downloading it, put it in a folder of your choosing. For me, I put it in Crack Me's folder, and then next thing is to install it inside your LD player. So let's click on LD player now and drop it in here, and then run it to see what happens when you run it. Straight away it says root detected. This is unacceptable. The app is now going to exit. So click on it and the app exit. So this is a perfect APK for us to learn how to hook the function that is detecting the root, and then how to bypass that function by modifying the function itself. So before we can know what function we have to hook, we have to first reverse engineer this uncrackable APK file and then decompile it. And then we study the decompile code, and then we'll understand which function we should hook. So we'll do that in the upcoming next videos. Thank you for watching. So in order to understand which function we should hook, we need to decompile this. So let's try to decompile it now. Just open a command prompt and then navigate to your folders that contains this APK file. So this is my APK file. So we need to decompile it. Decompiling is a two-step process, which I already explained in the lectures on how to decompile. The first step is to convert this APK file into jar files. So to do that, we need to use a program, the command called dex2jar, which we've already installed. So in order to run that, you need to type dj dex2jar, provide the name of the APK file, press enter. So it's the wrong syntax there. dj2 dex2jar, hit enter, v2j dex2jar, and now we have converted it into a jar file, as you can see from here. And then next thing we want to do is open this jar file with a program called gdgui. So for me, my gdgui is found inside my tools folder over here, as you can see. So I have to navigate into the tools folder and then type java -jar and then type gdgui, hit enter. And then from here I can open my jar file which I've just converted. Go to the crackmiss here, go to my crackmiss and open this jar file. And from here I can now analyze the decompile code. So as you can see, every program starts with the main activity class, and from here you see that when main activity starts, it will first go run the onCreate. So onCreate is the first function or the first method which runs for any Android program. So the first thing it does is it calls three functions: c.a function, c.b function, and c.c function. If any of these functions returns true, then it will print the function, it will call the function a root detected, and then it will quit the program. So what we need to do is to hook these three functions: c.a, c.b, and c.c. And these three functions come from this class, sgVantagePoint a.c class, which is here, a.c class, this one. So this class contains the three functions which you need to hook: a, b, and c function. And you can notice that from the signature of the function, the return type is boolean and is returning true. If the file, if it is detecting the root, then it will return true for a function, and for b it will also return true, and for here it will also return true. So our strategy is to force it to return false for all three. That is our strategy. So if you go back to the main class where the functions a, b, and c have been called, here, you'll notice that if any of this is true, it will detect the root. This is the meaning of this symbol. This symbol means all. So either c.a returns true, or c.b returns true, or c.c returns true, any of these true, it will return root detected. So we have to hook these three functions A, B and C to force it to return false for all three. That is our strategy. So in the next video, I will show you how to write a script to hook these three functions. And remember, these three functions are coming from this class SG Vantage Point. Okay, so that's all for this video. I'll see you in the next one. Thank you for watching. Hello and welcome back. In this video, we are going to start writing scripts to inject into the APK file, and we are going to hook the A function, the B function, and the C function. So let's open a new file in Visual Studio Code. Click New File, and then let's save it. So we are going to save it in the folder Frida scripts, and I'm going to call it crackme1 root bypass. And then the extension will be .js for JavaScript. And then the first thing we do is always to write Java perform and a semicolon at the back. And then inside it, we will put our anonymous function as usual, like this. So this will always be the starting point for any script that we write. And then inside our function definition, we will put all the code that we need. As I've already explained in the previous lessons, first of all, you need to identify the class that you are going to hook. And once you identify the class, you can then hook the function within the class. So first of all, which class do you think we need to hook? As I've explained in the previous lesson, the class that we are interested in is the B class. The B class comes from the A class, and A class comes from the SG Vantage Point class. So this is the class that we are interested in. Java SG Vantage Point.A.C. This one. Because from here, this C class is coming from this package. So we need to hook that. So we will create a temporary variable to store the hook that we get. And we are going to call it root check class. Root check class. And then we will use the Java use function and specify the class that we want to hook. In this case is sg.vantagepoint.a.c and a semicolon at the back. So after we run the Java use function, it will look for this class sgVantagePoint.a.c, which is this one, and then it will return the reference to that class and store it in this variable called this constant called root check class. Now we can intercept the function itself that is contained within this C class. So the first function that we are interested in is the A function. So to do that, we will now use the root check class object which we got from here, and then specify the function that we are interested in. In this case is .a. The first one is .a, see? So we put .a, and then we will put .implementation because we want to substitute the body of the A function with our own function. And this is how we do it. This is how we do it. So this way, we can supply our own function to replace the A's function. So whenever A function is called, instead of running the A function that is inside of here, instead of running this function inside here, we want it to run our own function, which is here. So this is the power of Frida hooking, and it's so powerful we can do anything we want with the function once we hooked it. Okay, so this is how we can override, this is how we can implement our own function to replace the one in the program. So now here, once we can hook it, for the start we just want to return a helper message, a helpful message, just to inform. Then we are inside like this. So we can just call we can just say, for example, bypass c.a function like this. So c.a is referring to this c.a here. But alright, so if you want to bypass it, what we need to do is to return false. That means our own version of the function is returning false. The original version of the function can return true or false. Take a look. st_vantagepoint.c class.a returns either true or false. So we want to tamper with this definition of the function to always return false. That is why we're returning false here. So when it returns false, it means that the no root is detected. So this will be false. Okay, so now we will save this and check, make sure there are no syntax errors. So now we'll go to our console and go to our folder that contains our program, our script. Frida scripts. dir confirm that this is our script there. And then make sure your Frida server is running. So once you confirm it's running, you can then do frida.ps-uai and check the name of the package. OAuth message uncrackable. Okay, that's the one. So over here, now we can run frida-u-f, and then we copy the package name, paste it here. Then we'll load our script, and our script is called crackme1 root bypass.js. We hit enter. And now it is started in a pause state, so we need to type resume, %resume, hit enter, and you can see here it is inside the bypass c.a. Okay, it is inside it. So this confirms that this is working. We are inside it, but we only bypass one. We have not bypassed the other two checks. Alright, so let's complete the thing. So we'll now quit this program. So remember, this bypass CA is coming from here. It is coming from here. Okay. Alright, so now let us quit this program and restart again. This time we are going to complete the hooking for the other two functions. So if we come back to our other two functions in JD GUI, now we come back to our program, and we can see that we need to do the same thing for the B function and also the C function. So that is easy. So all we need to do is just copy this line and paste it down here 2 more times. For this one, we change it to the B function, because over here you can see it's a B function. And then here we change the message accordingly, c.b function. And over here we change it to C function. So accordingly we change this to C function. and down here we also change the message to C function. Then we save. Now we can run our script again. Clear screen, repeat the command, hit enter. Now it is started in a pause suspended state, so we'll type %resume, hit enter, and you see bypass C.A, bypass C.B, bypass C.Z. See that? We already hooked all the three functions and managed to bypass it by returning false, false, and false for all three. So because all three are returning false, therefore this evaluation is written as false. So this if statement is false, so therefore it will not detect the root. Instead it will proceed to the next instructions. So this is how we can use Frida scripts to hook functions and to temper and modify with the function itself in order to bypass root detection. If you take a look at the solution provided by Novella, you will find that in here he uses this syntax overload. Now this is optional in our case because this function doesn't accept any parameters, but if for example your function will accept parameters, then you will put the overload in here, overload like this, and you might pass some parameters inside here. But in our case it doesn't pass any parameters, so therefore this syntax is optional. You can just write like this, a.implementation. Okay, I hope that helps you out, and so that's all for this video. Thank you for watching. Hello and welcome back. In the previous lesson we have already managed to bypass the root protection for this uncrackable 1 crack me using the root bypass.js script. And what we did was we ran the script, injected it like this, and then after that we resumed, and then we managed to bypass the tree protection. So now we are faced with this screen which asks us to enter a secret string and then to click verify. So if we just enter any string here and click verify, we find that we get a message which says nope, that's not it, try again. So now in this video I'm going to show you how to dump this string inside the script itself. So to do that we will have to write a new script. But before you write the script, let's try to understand what is happening. Now in the main class you will see there is a function called verify, and this verify here will use this function A and to test whether the string that is sent is correct or not. If the string that is sent is correct, then it will say success, this is the correct secret. Otherwise it will print nope, that's not it, try again. And this is the message we saw. So now I want to be able to dump this string, the string that is entered by the user. So how will I do that? So I will have to inject hook this function A. Now this function A is coming from the A class, and the A class is this class here, because this whole package is the uncrackable 1 class, which is this, and this A class therefore is this one. And over here this is the string, this is the function we want to hook, the A function coming from the A class. So in order to do that, let us start a new script by clicking new file here, and then let us save it, file save, and then over here we will call it dump we will call it dump string parameters, or just dump function parameters. .js. So the objective is just to dump this function parameter that the user enters. So the first thing we do is we call java perform, and then we create our anonymous function and we put a semicolon at the back, and then we expand the function body, and inside here we'll type our function. So we want to hook the class. So the class that we need is sgvantagepoint.uncrackable1.a, which is this one, sgvantagepoint.uncrackable1.a. This is the class. So we create a constant to store the class name. So the class name is class A. We will just call it class A. And then we use the Java use function and type in the name sgvantagepoint uncrackable1.a. So class A is referring to this class here, and this is the package name sgvantagepoint.uncrackable1.a. uncrackable1.a. Next, we want to hook this function A inside of this class A. So to do that, we will use the class A that we've got and then specify the A method and then put a dot here. Now this A function accepts parameters, therefore we will need to use the overload method because it accepts parameters. And in this case here, we have to specify the parameter which matches the string. So in Java, the string comes from java.lang.string class. java.lang.string. So that refers to this. If there were two parameters in here, then here also you can put a comma and then specify the second parameter type as well. So in this case, there's only one parameter. At the back, we use our familiar implementation method, and then we will now specify our own implementation for this function A. So we type the keyword function, and then in a parameter, we will have to specify a matching parameter by any name. We will call it S. So the number of parameters must match the number of parameters here. So in this case, there's only one parameter. Following that, we will specify the function body. After that, we can expand the function body and write our code. So our objective is to print out whatever the function string receives. So in here, all we need to do is type console.log and then the name of this string as and convert it to string, and then put a semicolon at the back of this line. Now you will note that this function A returns a boolean. That means it can be returning either true or false. So we need to also return a boolean, either true or false. So we will return true. You will notice here, this thing will return the result of this comparison equals. The param string is what the user enters inside the text box. If the string that the user enters equals the array of byte, then it will return true. So that implies that the key that is entered is correct. But we want to bypass this check by always returning true. Therefore, we can force it to return true by ourselves. That way, no matter whatever key the user enters, it will always be true. So with that, we can save this now and we can test our script. So now we will come to our program here, and then this thing is already running, so we have to reload it, exit the program first and reload everything. Kill this script here, clear the screen, and then in this terminal we will launch the root bypass first to let it bypass the root check. So we hit enter and let it start. It will enter the pause or suspended state, and then we need to type resume as usual. Now notice here we are using the root bypass to bypass the root check. So now we have bypassed the root check, we are ready to launch this script, to inject this script. So to inject this script, we need to open another new terminal over here, and we need to find out the name of the app. So we can use Frida ps-u AI to find out the name of the app. Now the name of the app is Uncrackable 1. So we will specify the name of the app, Frida-u-n Uncrackable 1. And then we will launch our script. So the name of our script is dump, or we need to go to the script folder first. And the name of our script is dump function parameter. So what we need to do is type Frida-u-n Uncrackable 1. Notice we need to use the name of the script. You need to use the name of the app rather than the package name. We cannot use the package name because package name requires a -f parameter, but we are using -n parameter. We can't use -f here because we already did that here. When we wanted to do the root bypass, we use a -f parameter and provide the package name. But here, we cannot use -f, we must use -n. So when we use -n, we need to specify the name of the app. The name of the app is Uncrackable 1. So next thing is to load the script. So the name of the script is here, dump function parameters. So now we hit enter and it will inject the script into the application. So now we are ready to type our string. Test 1, 2, 3. Then we hit verify and we say this is the correct secret. OK. And you can see it also dumps the parameter here. So this is our objective, to dump the parameter that the user enters onto the screen. And also as a side effect, we also manage to bypass the check. No matter what string you enter, it will always be success. So we have cracked this uncrackable crack me. So how it works is, let's take a look. In our main class, when you press the verify button, it will call this function, and then it will call this function, and inside here it will extract the string that the user enter. So the user enter string will be stored here. In this case, it will be test 1, 2, 3, and then over here it will send the test 1, 2, 3 into the function A, which is here. So function A will take your test 1, 2, 3 string, and then from here we will intercept it and then supply our own function. In this case, our own function will replace the function A. So we intercept it and then take the string that the user enters, test123 and then console log to the string. So console log to the terminal. And after that, instead of going through all these tests to check whether it's correct or not, we simply force it to return true no matter what. So when it returns true, that means it will come back to our main class here and it will return true. So no matter what we enter, it will always return true, and because of that, it will always print success. This is the correct secret. So we have managed to crack this CrackMe even without finding the correct key. So that's all for this video, where you have learned how to dump the function parameters and also how to bypass the checking for the key to always return true. So that's all for this video. Thank you for watching. Hello and welcome back. Remember that we are still working on this uncrackable 1 CrackMe, and in the past few lessons I've already shown you how to bypass the root detection by using the script, root bypass script like this, and I also show you how to dump the string parameter that is typed in by the user, and also in the process how we can force it to accept any string as a correct password. And that we did it by using this script. So now in this lesson, I'm going to show you how to actually find out the real actual password, the correct password. So if you remember, we already decompiled the source code for this APK, and the password checking is done in the verify function of the main activity class, and it is done specifically in this function A here. So if this function A returns true, then it will show success. Otherwise it will show nope, that's not it, try again. You can actually try it now and confirm for yourself that that is really happening. If I just enter any wrong password and click verify, it will say no, that's not it, try again. So this bad message is actually coming from here. So now in order to get it to show this good message, success message, we need to dig into this function to see how it works. In order to understand this function, we can just click on this function A here, and it will take you to that function, which is here. So this function is coming from the class A of this package. So in this lesson, I'm going to show you how you can find out the real password. So as you can see here, the user password is sent to this function in this parameter, and then it does some operations, and then finally it will compare this user password with the correct password. So this correct password is coming from this function and this function. So these two functions here ultimately will create the correct password, which is this array of bytes over here. So our objective in this video is to try to print out, console log this array of bytes to see the actual password. So in order to do that, we need to understand how the decryption works. As you can see from here, in order to get the correct password, you need to call this function A. So this function A accepts two parameters, the first parameter and the second parameter. And the second parameter is coming from here, the result of this first function call called base64 decode. So base64 decode's function is to decode this hash into a decoded array of bytes, and this array of bytes is passed as a second parameter to this decryption function. So we can assume therefore that this is a decryption function, because what you get from this decoded text is the ciphertext or the encrypted text. So the encrypted text needs to be decrypted using this function. over here we are only decoding from hash into text. So the text that is being decoded from the hash is still encrypted. That is why we still need to use a function in order to decrypt this ciphertext into plain text. So over here we can assume that since this is the input for this decryption function, this must therefore be the key, the decryption key. But as you can see here, even the decryption key is some kind of encrypted text. And it has its own B function to decrypt this string. So we need to call the B decryption function to decrypt the key. So you can see this has multi-level security. So, and then finally, once you get the array of bytes, you can then convert it into a string and console log it. So that is our target. We have to somehow find a way to write a script in order to implement all of these functions inside our Frida script. So let's start off by first trying to understand the basic building blocks of our Frida script based on this code. So go and open your Visual Studio Code, and we will start a new file, and inside here we will write java.perform as usual, and then at the back we put a semicolon, and inside this we put our familiar anonymous function, and then we will open the curly braces in order to add our implemented code. So we will now try to write the skeleton for our algorithm to solve this problem. So the first part that we need to do is to implement this base64. So in order to implement base64, we must make use of this base64 class. So in order to do that in JavaScript, we must create a JavaScript wrapper for this base64 class, which is coming from here. So as you can see, this base64 is coming from this class. So we will declare, so we will put a remark here to say that this is a base64 decoding functions. Let us save this first. We will save it as inside our Frida scripts folder, and we will call it decrypt and show. Decrypt and show .js. So now we can see the colored code. Alright, so next, our second skeleton will be this part in here, this B. So this B is coming from where? If you want to know where this B is coming from, you can just click on it and it will show you here. Therefore, this B is coming from this class, A class of this package. So in order to create a wrapper for that, we need to use Java use again. So this part here, we will call it B function. So this B function is coming from here. From here. B function coming from this class. And then after we did that, the third thing we need to do is to decrypt it using the A function. So we write our skeleton for the A function over here. So this will be our A function. And then finally, once we call the A function and already decrypted the ciphertext into plain text, we have an array of bytes. The last step is to convert this array of bytes into a string. So the next fourth thing we need to do is convert to string and show. Alright, and show the actual string itself, the actual password. So these are the four skeletons that we identified that we need to implement in order to solve this problem. So with that, we will stop here for now, and in the next video we'll go through the detailed steps of how to implement all this code inside your JavaScript, Frida script. So that's all for this video. Remember to save, and I'll see you in the next video. Thank you for watching. Welcome back. In the previous video, we have already studied the algorithm for the decryption, and we have already identified the skeleton of our Frida script. So in this video, we are going to implement the function definition itself inside the Frida script. The first is the base64 decode, which is over here. So base64 decode, we need to create a Java wrapper for this base64 class. So to do that, we will declare a constant first called base64, and we will use Java use function, and inside here we will name this string for this base64. It is actually Android util base64. Android util base64. Okay, once we have done that, we can now call the decode function for this base64. So we have already created the Java wrapper out of this Java class, and we can now use the Java class through its wrapper. So we call base, we will have to save the result of this function to an array of bytes. So we will just create an array of bytes variable, and then we will call base64 the wrapper and call the decode function, and inside here we will pass this parameter, these two parameters. So I will just select this, Ctrl C to copy, come in here and Ctrl V to paste. So I've got these two parameters coming from here. So once you have decoded it, you can save it into this variable array of bytes. The next step is to use this B function. So in order to use this B function, we need to create another Java wrapper for that, a JavaScript wrapper. So we will call it constant B function class, and then we use Java use, and inside here we are going to use the B's class. So we click on B, you will see that B is actually down here in the same class as this one, A class. So this class can be accessed using sgVantage.1 uncrackable1.a. So that's what we're going to do. Inside here we are going to sgVantage.uncrackable1.a, and then put a semicolon at the back. So now that we have already created a B function class for this wrapper, a wrapper for this class, so now we can use it. We can use the B function by creating a variable called encryption key. After all, this function is to decode this encryption key, so that's why we call the variable that it will receive as encryption key. So in here we can call the B function by using the wrapper bfunc class dot, and then here would be dot B, which is this one, dot B. So over here we are going to copy this parameter, Ctrl C, and then inside here we are just going to paste it in here and put a semicolon at the back. So the purpose of B function is to decrypt the encryption key and save it to array of bytes. Now the next thing is to call the A function, which is this A function here. So we need to create a JavaScript wrapper for this A function. So the A function is coming from this class sgVantagePoint.a.a.a.a. Okay, so we create a wrapper class for that as well, call it the A function class, and Java dot use, and this one will be sg vantage point dot a. After that, we can create a variable to receive the decrypted array, and then we will call the A function using the JavaScript wrapper A function class dot A, and then we will pass two parameters, the encryption key. So this one is encryption key. So this encryption key now is stored in this variable. So the first parameter will be enc key. The second parameter would be decrypted decoded array of bytes. So it will be this one, this array of bytes here. So array of bytes. That's it. Now the last step, after you have got the decrypted array, the last step is to convert it into a string. So this, we are going to implement this here. So this string is coming from Java lang string class. So we first have to create a wrapper for that. We will call it string class Java use Java language string, capital S, string. So now we have got the string class, we can convert this array of bytes into string by using a new constructor keyword. So in JavaScript, the new constructor keyword is the $new. So we have to first create a variable, decrypted password, and then we will use the string class and then use the new keyword with the $in front and pass the string class, not the string class, sorry, the decrypted array, decrypted string, decrypted array, which is this one here. Okay, so this is a new notation in JavaScript. You can refer to the Frida documentation. So let me show it to you. Over here under Frida documentation, you go to JavaScript, to the API reference for JavaScript, and then scroll down, look for Java instrumentation, and then if you scroll down, you will find there's a reference there on how to create new objects using this $new. See, Java use dynamically creates a JavaScript wrapper for your class that you can instead set objects by calling new. So that is what we are doing. We are using this new notation over here to create a new string over here. As you can see, this string is a Java class, so we use the Java use to create a wrapper out of the string class. Once we got a wrapper, we can use the new keyword in order to create an object out of it. And the final thing to do is to console log your decrypted password. That's it. Okay, so now what we need to do is to restart our program, our APK. So we need to have two console open. The first console will be to use the root bypass, which is this one, crack me root bypass. So we'll do that first. So at this point, make sure your Frida server is running before you proceed. So mine is already running, so I will do a Frida dash u, get the name first. So you can see the name of the package is com OAuth MSTG uncrackable one. So I'll just right click and copy this, then I will use it here. Frida dash u dash F, right click to paste the package name, dash L to load my root bypass script, then I hit enter. So now it will launch the APK and in a suspended state, so I have to type resume to continue, hit enter. Alright, so now I have to inject my decrypt and show script into this running process before I enter, before it will show the script, before it will hook the decryption function and show the console log here. So to do that, I need to open another console because this one is already been used. So I go to search, command prompt, I have to navigate to my Frida scripts folder, and do a dir to confirm that my script is there, decrypt and show. And here I need to call Frida-u-n and pass the name of the crackme, which is called uncrackable one, and then load the decrypt and show script. Over here, because of -n, I have to make use of the name of the app, not the package name. Package name is used when you are using -f over here, -f, then you use the package name. So here is -n. Okay, so now press enter and see if it works. Just hit enter. So n key is not defined, and I have an error at line 12, JavaScript line 12. So let's take a look. Line 12, n key is not defined. Yeah, so it's a wrong spelling. So let me correct it. N key. Alright. So when I save this, it will rerun. So let me see. I save it. Control S to save. And then if I go back, I should be able to see new output. String last is not defined. So I have another error, line 16. So string last is not defined. Okay, so another typo error should be string class. Control S again, and then it will rerun. And now it says decrypted password is not defined. This is in line 17. So go back here, decrypted password. It should be decrypted password. Decrypted password. Okay, it's a wrong spelling. Alright, so here should be DCRYPT, decrypted password. Save again, and this time it should be fine. Let me kill it and try again. Yes, this time is correct. See that? It prints the password I want to believe, which is coming from here. So now we will test whether it's correct or not. We key in this password, I want to believe. I want to believe. Hit verify. Correct. Success. This is the correct secret. Okay. Alright. Let me try to key in the wrong password by putting extra characters. And it keys, nope, that's not it. Try again. So that means we have successfully solved this crackme by using this script. So in this session, I taught you how to identify and understand algorithms inside a function, and then how to implement those algorithms inside your own script, inside the Frida script. and how to use wrappers to wrap the Java functions, Java classes, and how to call those functions making use of the wrapper, the JavaScript wrapper. And also finally, how to decrypt the encrypted key and show the real key. That's all for this video. Thank you for watching. Hello and welcome back. We are now going to take a look at Windows Crack Me and how we can use Frida to reverse engineer it. So you can go and download Windows Crack Me from this website here and head over to this reversing these challenges here. Click on challenges. And then scroll down to number 3, and we are going to download Crack Me 1 from here. So just click on this one to download Crack Me 1. It will take you to the GitHub and click on this link to download Crack Me 1. So after you have downloaded Crack Me 1, unzip it. You need to provide the password to unzip. The password is crackinglessons.com. So just unzip it and put it in a suitable folder of your choice. So I put mine in this folder here. So when I run it, it says please enter serial key. And if you enter the wrong serial key, click check. It says wrong serial key, try again. So we are going to use this Crack Me to study how to use Frida on Windows programs. So you can download this Crack Me also from the resource section from this for this lecture. So you can also download this script, listmodules.js. This will be our first script for this lesson. So open the command prompt and then navigate to wherever you put your script. For me, I put my script in the Frida scripts folder, which is this one, this modules, and I put my Crack Me inside this location, Frida Windows Projects Crack Me. So over here, I'm going to run my Crack Me, typing Frida -f, and to run the Crack Me, I will have to go up 2 steps to the parent folder. My parent directory is up here, and type Crack Me / and the name of the Crack Me. Then I will load my script, my list module script, and hit enter. So now it has loaded the script and it has executed it. As you can see, it is supposed to list all the modules here. So to list the modules, we just use the process class and call the enumerate modules function. You can refer to the Frida documentation to learn more about it. Click on docs here, scroll down to JavaScript API, and then scroll down to process, and you can find, scroll down to modules. Yes, modules. So here is where you will find the function enumerate modules. So enumerate modules return an array of objects. So we click on this, you can see the explanation in detail. So process enumerate modules loaded, and it return an array module objects. So it returns an array. That's why I created a constant here to store the module array that is returned. And then after that, I use a loop to go through the module array. So, and for each element, I will print out the name, dot name. So the dot name here, you can get the reference from module. Click on this module link here, and it will tell you that the module contains a parameter called name. That is why you can put dot name here, and it will print out the name of the module. So these are all the modules that are found inside this CrackMe, all the modules. And then if you click on check, it will tell you the message. It will show a message box. So message box comes from user32dir, comes from this module, user32dir, and you can confirm that by going to this by opening a browser and then searching for MSDN message box. And then you get the MSDN reference here. So this is a message box API. If you scroll down, you will find the module where it came from. There you go, user32dir. So this is where the message box comes from. Alright. Okay, so the message box has got two versions, the A version and the W version. The A version is 8-bit, that means single byte, ASCII, and the W version is Unicode. So you have two versions. So in the next lesson, I will show you how to intercept, how to hook the message box function. So this is the first introduction to using Frida on Windows by writing a simple script to list all the modules that are loaded by a particular Windows program. If you press resume now, you key in resume now, hit enter, the program will run. So it's similar to the Android. So that's all for this video. Thank you for watching. Hello, welcome back. So we are going to continue with our exploration of the CrackMe 1, which you downloaded in the previous lesson. This CrackMe 1, and this time we are going to hook a message box function. So go and download this script here, hook message box.js, from the resource section for this lesson. And inside here you will find there's a class called module and then there's a function coming from this class, which is find exports by name. So this function accepts two parameters, the module name and the API that we are interested in. As I explained before, the message box has got two versions, the A version and the W version. The A version is for ASCII and the W version is for Unicode. If you're not sure which one it is, you can try the A version first. Later on, if it's wrong, you can put the W version. And then inside here, we use the interceptor attach, and we are going to intercept the message box. So over here, we get the address of the message box API from the module, save it in the constant here, and here is where we attach to that address. And then you also have a callback function. So the callback function starts from here and ends here. Inside it, we will implement two labels, two functions, on enter and on leave. On enter will be defined here, and here is where we are simply going to print the entered message box, and then we want to read the first argument. So this first argument here refers to the first parameter, which is this one, LP text. This is argument 0, argument 1, argument 2, argument 3. So argument 1 is the text that is displayed inside the message box. So and then argument 2 is the caption of the message box. The caption is the title of the message box. Let me just explain what I mean. So when you click on this, it shows the message box. This LP text 1 is this message, wrong serial key, try again. This caption here is the title of the message box, sorry. Alright, so this only the are two things we are interested in. So we want to print out this in the console. That is the purpose of this script. We want to print out. So the way we print out is we get the arguments and we access the first argument for the text. And if you want to print the caption, you will print the argument 2 for caption. Argument 2 is caption. So to print argument 2, you just have to copy this line here and put it down here, and then here you put 2 and change this to LP caption to refer to this one here, LP caption. Alright, and then this function on leave is called when you exit the message box. So let's see how this works. So we are going to go back here and call our Frida program again, but this time we are going to inject this script. So let's repeat the command, but change the script to hook message box JS. Hit enter, and you can see here spawning the address of this, and then over here he asks you, oh, this address of message box is coming from this line here, address of message box, and he prints the message box address which he got from this function. As you can see, the address is in hexadecimal, and then now it's waiting for us to hit resume. So we are going to hit resume, then our Windows shows up. So now we're going to type any wrong serial key, hit check, and you can see it prints out entered message box, and also the pop-up comes up. So this entered message box message is coming from this line here, entered message box, from this line. Thereafter, you will go and print the second line, LP text wrong serial key, try again, is coming from here. LP text wrong serial key, try again. Memory read UTF-8 means to convert this address into string. So args1 is actually an address of a string in memory. We cannot just print args1. If we just print args1, it will print out something like this, an address. So we have to read the string stored at that address. That's why we use this convenience function called read UTF-8 string. Now, if this was message box W, then this will be read UTF-16 string. Change the 8 to 16. So 16 is used with message box W. Alright, so over here, the caption will show next, coming from here. Alright, and then finally, when you exit the message box, so you can see here, sorry is the one over here, the caption, and wrong serial key, try again, is the text here, LP text. Okay, what happens if I click OK? When I click OK, it prints this one, exited message box, which is coming from here. So when you exit the message box, you will trigger the onLeave function. That is when the message box quits. That's why you print this last line over here. So you can see now the power of Frida in hooking Windows functions, Windows API. Okay. Alright, the other thing I want to mention, this one, message box A and W. If you change this to W, if let's say A does not work, then you put W over here. And if you put this as W, this you must change to 16 as well. 16, and 16 as well. So just to remind you, so W is for Unicode, A is for ASCII. So we're not sure beforehand our program is written in Unicode or in ASCII, so we just try one, or if not, then the other. So you must change accordingly. If you use W, this change to 1616. If you use A, this one will be A, 8 and 8. So if I save this now, you will see that over here, you will not be able to see the string, because this is in ASCII, not in Unicode. Alright, so that is why you need to change this back to 8, and here also change this back to 8, and then here also change this back to A for ASCII. Then you should be able to see the message. So let's try run it again. Click check, and you can see wrong serial key. Try again. This is how you can intersect. This is how you can hook the functions, the API functions in Windows. That's all for this video. Thank you for watching. Hello and welcome back. In this video, I'm going to show you another technique. Previously, we have seen that this is the correct me one. When you enter a wrong serial key and you click on the check, it shows you this message: sorry, wrong serial key, try again. Now in this video, I'm going to show you how you can show the correct message, a good message, even though the key that is entered is wrong. Still, a good message should be shown, a congratulatory message like congrats, well done. And I'll also insert icon here for this message box. So that is the objective of this lesson. So let's close this. I also want to inform you that one of our earlier lessons, I showed you how to hook the message box using this script, hook message box JS, and this is how we hook it. We find the export name for the message box function from the user32 DLL library, and we save it to a message box constant. And then over here, we use interceptor class to attach to that address, the message box address, the following callback functions. And then when we want to read the arguments for the message box, we can use these arguments here, which is the return value, which is the parameter that is returned by this callback function. So arguments here is an array. The array contains 4 elements: arg0, arg1, arg2, arg3, and arg4, which you remember is found in this MSDN reference, which I already discussed in the previous lessons. This is argument 0, argument 1, argument 2, argument 3. So 4 arguments. So now I want to inform you, instead of using memory.read UTF-8 string, you can also do it like this. You put a dot here followed by the function read UTF-8 string at the back. This will also work. So let me try this and show you. So now if you open a command prompt, go to your Frida scripts folder for Windows, and then we run our Frida program, Frida tool, and then pass the name of the correct me, which is in the correct me's folder. Then we load the script, hook message box version 2. So hook message box version 2 uses this syntax .read UTF-8 string. So the first version uses this syntax memory.read UTF-8 string with the parameter inside. So now I demonstrate to you this method. So I hit enter now. So then we hit resume. enter, and now we see the windows have popped up, and we enter any wrong serial key, click check, and it says wrong serial key, try again, and inside here you can see it prints out entered message box coming from here, and then inside here it prints the LP text, which is the text shown inside here, inside the message box itself. This is the message box itself, the text, and then the third one is the caption, which is the title of the message box. It prints here. So this also works. So that's all I want to tell you. So now let's work on our new script. So go and download this new script, modify message box.js. So in this script here, I'm going to hook the message box function again. You can use get export by name or find export by name. Previously we used find export by name, but now I want to show you another method, get export by name, which is exactly the same. Then over here we allocate two strings using this function, memory alloc UTF-8 string and memory alloc for both. One is the well done, which will replace the text inside the message box, and the other one is congrats, which will replace the caption inside the message box. Then we attach to the message box using an interceptor, and then we have two callback functions as before. Now over here we will first read out the existing message by calling the args1 read UTF function for args1 and args2, and then after that we will substitute args1 and args2 with these two new strings. So well done will be assigned to args1, congrats will be assigned to args2. Not only that, we will also create an icon for the message box. So the message box icon, if you refer to the here, is coming from here. All these are message box icons. So if you put value 4, that means you want to show the information icon, which is here. Just ignore the L. So just copy from here up to 4 and then put in here. Now all these are pointers, therefore that's why you need to use a pointer function to convert this string into a pointer and assign it to args3. So args3 is your third argument, your fourth argument, sorry. This is args3. args3 is the icon type. So you can refer it to down here, the icon type. So now let us try to run this and see how it works. So I'm going to change the load message to message box, modify message box.js. So hit enter. Now we type in resume, and now we inside here we key in any wrong serial key, click on check, and you see well done, congrats, well done. So even though the serial key is wrong, it still shows you a congratulatory message. Why? Because over here we have replaced args1 with the well done message, that's why it's showing here, and we replace args2 with the congrats message, which is the caption here. And then we also add a pointer, we also add an icon for args3, that's why you see this icon here. And then in the output here you can see the usual output. Over here it says wrong serial key, try again, which is coming from here. This is coming from here. This is before we replace the args1. And then the second message is sorry, which is also coming from here, and this is also the caption before we replace the caption with the new text. And then at the bottom here, now if you click OK, it will show the exit message because of this. So this is how we can modify a function inside the Windows API and change the behavior or the text or the icon of the function. I also want to refer you to some documentation. Over here you can see Frida best practices. So if you come up to this, you will see Frida best practices. So this is where I got the code from the Frida best practices documentation. So it says that if you wanted to replace a string, you can do it this way. You declare a global variable first for your new string, and then you assign that string to your argument. So that is exactly what we are doing here. We declare this global variable here, the two strings, then down here we assign those strings to the respective arguments. So that's how I got the technique from. And then the other reference for you is this one. This reference is the native pointer. Native pointer is referring to this args1, args2, args3. They are called native because this is written in C++. Unlike the Java, which we did when we were hacking the Android apps. So because it's written in C, and C is a native language for your Windows, therefore it is called native pointers. All this. So native pointers, you have all these function and properties of native pointers. So you can see here the read UTF-16 string, read UTF 8 string is coming from here. So that is what we employ here, read UTF 8 string and 16 string. Okay, so as I explained before, if your message box is message box A, then you should use read UTF 8 string. If your message box is message box W, which is Unicode, then you should use read UTF 16 string. So it's all documented here as well. Alright, so these are all the UTF-8 and UTF-16. So that's all for this video. In this video, we have learned how to intercept the function, and in this case, we intercept API called messagebox, and we modify the string as well as the caption and also the icon for the message box. So, and then also we saw how we can create strings for use inside our functions, interceptor functions. That's all for this video. Thank you for watching. Hello and welcome back. In this video, I'm going to show you how to list the functions imported by a particular program. Go and download CrackMe 2 from the resource section for this lecture. After you unzip it, put it in the folder of your choice. For me, I put it in Frida scripts here. So now when I run it, it opens up this window and says unregistered software, please crack me. And then over here there's an about also saying the same thing, and if you click OK, it closes. So we are going to use Frida to crack this crack me. So in the first thing that we need to do is to learn how to list the functions that are being imported by this program. So for that, you need to have this script, which you can download from the resource section as well. So after you have downloaded it, let me explain to you how this thing works. We use a load function from the module class, and then we load the module crackme2.exe, and then we save it to a constant called module. After that, we call the enumerate imports function from the module, and then that will return an array of functions, and we save it in the variable called functions. Thereafter, we will look through these functions and print out the name of every function that is imported by this module crackme2.exe. So let's try that. So I type dir and I can confirm that the crackme2 is in this folder. So I will run Frida -f and then the name of the crackme, which is crackme2. Then I will put a -l to load the script, which is listfunctions.js. And if I don't want the thing to pause, I can put no pause at the back. This will prevent it from entering the suspended state. Instead, it will just run the program directly. So I hit enter now, and you can see the program starts, and then here it lists up all the functions that are imported by the crackme2exe, and you can see all the lists here. Some of these functions, all these functions are the Microsoft API functions. Some comes from kernel32.dll and some come from user32.dll. So this is how we can list all the functions. So for your reference, you can go and check the Frida documentation over here. So module load is coming from here, this reference, and then over here you can see there is a enumerate imports function. So this is where I get the script from. Here is where the module load function is called, and then after you load the module, you save it in constant module, and then you enumerate the imports, which is coming from here. So enumerate imports return an array of objects. So the array of objects is stored in this variable called functions, and this array of objects contains the following properties. It's got type, whether it's a function or variable. It's got a name, it's got a module address, and so on. So all this can be used if you wanted to, but for this particular script, I'm only using the name property dot name over here. This is how we can list the functions. Now the reason why we list the function is because we want to see how this program can be cracked. So from here we can try to make some guesses as to how to crack this program. As you can see, when this program runs, straight away it opens up. It already knows that it is unregistered. How does it know that? Only two ways. One way is either it checks the registry for a particular data, or second way is it checks for a particular file. So if you look through all the imported function here, you will find that there is one interesting function called create file A and read file as well. So these two seem to suggest that it is looking for a file. If you scroll down, we don't see any open registry function. Therefore, it is not checking the registry for whether there is a license or not. It is checking for a file. So this will give you a hint that we should now hook this function, create file A. Either create file A or create file W. Now please note that even though the name is called create file, it is actually not necessarily creating files. These functions are also used to open files for reading, and you can refer to the MSDN library and documentation here, create file. So create file A and create file W are two different versions. A is for ASCII and W is for Unicode. So if you're not sure, we will try one. If it doesn't work, then we try the other one. So let me explain first. Create file A accepts all these parameters and returns a handle. And the first parameter is the file name. And then here is what is the desired access. So desired access is explained here. The desired access can be summarized as either read, write, or both. So you can open a file for reading or for writing. So that is why I say that create file is not necessarily for creating files. It is also used for opening a file for reading. So in this case here, we are not sure whether it's opening for reading or for writing, but most probably it's opening for reading because it is probably checking whether or not a licensed file exists. That's why it is showing unregistered software, because it couldn't find the file. So that is just a guess. So now we are going to, in the next lesson, I'm going to show you how to hook this function to see what file it is looking for, and we can find out what file it's looking for by hooking this function and then print out the first parameter, which is this one. So I'll see you in the next lesson. Thank you for watching. Hello and welcome back. In the previous lesson, we already used a script list functions to list all the functions that are imported by the CrackMe tool. So in this lesson, I'm going to show you how to hook this create file A function to see what file it is looking for. So to do that, go and download this hooking files script from the resource section. And then put it in your folder, same folder as your CrackMe. So the hooking files is put here and your CrackMe is here. So now let me explain how it works. So over here, you use the getExportsByName function from this class module and pass the two parameters. The first is the DLL file that contains the function createFileA. Now how do I know it's kernel 32? You can check from the MSDN. If you go to this MSDN createFileA reference, and if you scroll down to the bottom, you can see the DLL that contains this function. And here it is, kernel 32 DLL. That's how we know. So if you want to get the module handle, the module address, you should pass the kernel 32 DLL and the name of the create file function as well. Now we're not sure whether it's A or W because we saw that in the list module list function script that there are two, A and W. So we're not sure, we try A first. If A works, then we don't need to go to W. But if A doesn't work, then we try W. So after we get the address for this file, we save it to a constant. And then here we will print out the address, and then we will then intercept using the interceptor. We will attach to this function by using the address here, and then we have the callback functions on enter and on leave, and then here we will print some helpful messages to tell you that we have entered the function, and then also print out the arguments 0. Argument 0 is the name of the file it is looking for. If you go and look at the MSDN reference, this is argument 0. So that's how we can know what file it is looking for. And then argument 1 is the desired access. That means, is it opening the file for reading or for writing or both? So that is argument 1. So if you look at this, argument 1 is a desired access. So from here we can know the purpose of what file is trying to look for and what is it opening it for. Is it for reading or writing? And then after that, the return value we can also check from here. When the function exists, we can print the return value here. So the return value is a file handle. So if you manage to find the file, the return value handle should not be negative. It should not be an error. So let's scroll down and see the return value. See here, if the function succeeds, the return value is an open handle to the device or mail slot. If the function fails, then it returns an invalid handle. So normally when it fails, it will return -1, which you will see in a while. So let's try this now. We will now call dir to confirm that we are in the right folder. CrackMe 2 is there, and our hooking files JavaScript file is also there, so we're going to inject it into CrackMe 2. So let's run our script now. So here we change this script to hooking files. So this will be our new script. So now we press enter, and here you see the program starts. And now over here we can see some readout. This line create file address is here at this address, which comes from here. So we already got the address of the create file A API, and we are printing it out here. So this is the address. And then after that, the next line is here, entered create file. That means when you entered the create file function, you print this line. And then the next line is lp file name keyfile.txt, which comes from here. So this is the file it is looking for. It is trying to look for this file called keyfile.txt. And then here, the next one is a desired access, which is printed here. The desired access is this value 8. So what is 8? So you can refer back to the MSDN for the desired access. So desired access is here, and it returns a D word. A D word is an integer. So let's look at the explanation for desired access. So desired access here says that the required access to the file which can be summarized as read write above. And what you want is a file access write constant. So if you open this one, this link here, the constant, you can see what is the value for 8. What does 8 mean? So access write constant, look at this 8. Okay, this is actually not 8, this is hexadecimal 8. So this is in hexadecimal 8, it is not decimal 8. So this hexadecimal 8 means file read attributes. That means it is trying to open the file for reading. So now we know it is trying to look for this file for reading, not for writing. That means this suggests that this file is most probably the license file that it is looking for. And then after that, to confirm our suspicion, we look at the return value. The last line. When we exit the create file, we can print the return value. The return value is printed here and is -1. So FF, all F's means -1. So when you convert it to decimal. So that's how we know that it is an error, you couldn't find the file. So that means if you go back to this, as we have seen earlier, when a handle is a negative value, it means that there's an error, you couldn't find the file. That is why it is unregistered software. So in order to solve this challenge, all we need to do is create the file that is looking for, keyfile.txt. So we come back to this folder, the same folder containing the crackme2.exe. You create this file, keyfile.txt. So just right click here, new, keyfile.txt, hit enter. Now we close this and then we clear the screen and we run our script again. And this time it says registered to. If you click about, it also says registered to. So and the return value now is no more -1. It is now a unique positive number. That means it's a handle to the file that it has found, this file. So this is how we can solve this crackme challenge. Okay, so in the next video, I'm going to show you how to change this string here to put a name. That means we want to put a name at the back, registered to such and such, and here as well. So to do that, we will use another method, memory scanning. We will scan the string inside memory and then substitute the string with a new string. So I'll see you in the next one. Thank you for watching. Welcome back. In the previous lesson, we already managed to solve this challenge by hooking the create file API and then finding out what file it is actually looking for. And then once we know that what file it is looking for, we created a file that inside the folder here. And so now if we were to run this program directly, you will find that it doesn't complain anymore about unregistered. Instead, it says registered to. And you click here, it also says the same thing. So in this video, I'm going to show you how to change this text to a name, registered to, and then a name at the back here. So in order to do that, we will need to scan the memory for this string, and then once we found the memory address containing this string, we will substitute it with a different string. So we need to use the technique of memory scanning. So memory scanning, you can check it here under the references. You go to the JavaScript API reference, and then you look for memory over here. So we'll make use of this method, memory scan. Alright, so now we can go and download this script, scanstrings.js script, and then put it in this same folder that contains your CrackMe2. So my scanstring JavaScript is here. Okay, let me explain how this works. So the first thing you need to do is to list out all the memory which contains this read and write permissions. We use that by using the process class enumerate ranges function. You can check it out here. Enumerate range. Here you go. Enumerate range over here. So the process enumerate range function, inside here you put what permission you want to enumerate, whether it's read and write or read, write and execute, and then it will scan through the memory for that particular process and then return the addresses. So over here you need to specify the type of permission that you are scanning for, what kind of permission in memory. So this function will return a range. So this range is actually an array. So because of that, you need to create an array here called, I will call it memory range. So this memory range is an array. So if you uncomment this, you print out memory range, you will see array. So let me just show it to you now. Over here, I'm going to comment this out. Okay, so now I enumerate all the memory for this process and then save to an array. So I'm only interested in the readable and writable memory. So let me clear the screen first. And then I'm going to change the script to scan strings. And hit enter to run it. And you can see object, 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 object. So all these are arrays. The square bracket means it's an array. See that? And this is coming from this console log here. So it's printing an array. So we have 1 array, 2 array, 3 array, 4 array, 5 arrays. There are many arrays here. Alright? Many arrays here. Alright, so this is how it works. So now we have the array. What we need to do is search for a particular string in the array. What string are we looking for? We are looking for a very specific string, registered to string. So where did this register to come from? If we run our program now, you will know. We are looking for this string called registered to, which appears here as well as here. Okay, registered to. But in this our script, we cannot put the word registered to inside here. You have to convert it into hex. So to convert it into hex, you use an online tool called ASCII to hex. This is the one, ASCII to hex. Then here you put the text, and then you click convert, and you get the hex version for this string. Then you copy all this and you paste it here, inside here. So this is the string that you want to search inside your process memory. So this is how you do it. I'm going to uncomment all this now so that you can see it in action. We need to look through all the array. That's why we need a for here. So this for will go through all the array here, and for each array here, you are going to scan. You are going to scan the start of the address and the size of the address. So every one of these range here contains the base, the size, and many other things. Let me show you. So I'll search for memory again. Now take a look at this. Memory contains address and size. Correct? Whenever you are scanning for something, you need to provide the address and the size. So the address here, the example given here, you can see the first address, the first parameter is the base address, that means the start of the address for starting the scan. The second parameter is the size of the address. That is why we need to do it like this: memory.base, memory.size. So the I here refers to the elements in the array. So the first loop I with 0, so you are scanning the first range of address. That's why you put I in front, so that you can look through all the memory ranges. And then here, the third parameter is your search string, which is coming from here. This one, registered to. And then here is a callback function. So this is explained in here. The callback function looks like this. On match and on complete. You have two functions you need to implement. On match, do something. On complete, do something. Right? You can do it this way, or you can do it this way using labels. On match is, on complete something else. Alright? So if you want to implement an on complete, you can put on complete here, and then function, and then implement your on complete function here like this. And inside here you must put some messages, console log for example. Like that. Alright, so we are just using the code, borrowing the code from the documentation for Frida. On complete. Okay? Like that. You also have on error. If you want to implement on error, you can do that. Right? On error. So you can put on error here if you want. On error function, and then here is the reason for the error, and then here you can print. You must put a comma, remember, put a comma, otherwise. And then here you can put the console log, and then here you can give some useful error message, reason. You print out the reason. Okay, so the on error also we borrow it from here, the reason when there was a memory access while scanning, so we need to print the reason. So this will make your implementation complete. Okay, so supposing it managed to find your string registered to, what do? You can print out. So in the meantime, I'm not going to do anything to the string, I just want to print out. I'm going to print the address where the string was found, and also the string that is stored at that address. At that address. Okay, so let's try this out now. Scan string. So let's clear and call this now. Hit enter, and you can see this is the address where the string registered to is stored in memory, and this is the string that is stored there. So these two lines, this and this, are coming from this and this. Maybe I can comment this out so that it's clearer. Let's comment this one out so that you don't see all this thing on top. Let me try it again. Okay, I'm going to clear screen and try again. Okay, so now you see it's clearer. This address is the address coming from here, where the program has managed to find where the string registered to is being stored in memory. And then the second string is registered to, which is coming from here. So this read out the string that is stored at that address. Okay, so now the next thing you want to do is to modify it. So to modify it, over here, right? So we want to modify it to this string registered to, and then at the back here we can say crackinglessons.com, for example. After that, we print out. This is to confirm whether we have successfully written this new string to that address. So now we save it, and then we run again, and you can see here registered to crackinglessons.com. We click about, it says the same thing, so it's working. So let me explain how it works. Now you can see these two lines that we've seen before is printing this and this line and this line over here, and this line is coming from this instruction, address.read UDI string. So this is where you console out the new string that is being written to this address, crackinglessons.com. Alright, so now when this script has found the memory that contains the registered to string, it returns it in this parameter called address. After that, over here we write this new string to this address using the write UTF-8 string function. Write the new string to this address. So that alters this string to become a longer string, a new string, and then the next line simply prints out the new string that is stored at that address. Alright, so this is how it works. So in this session, we have already learned how to list out the functions in a particular program that is running, in a particular process that is running, and then to analyze the list of functions that are imported, and then to target a specific function and analyze it deeper to see how we can modify the various values inside the function in order to crack this software. So that's all for this video. Thank you for watching. Burp Suite is a very useful tool for intercepting network traffic. So download Burp Suite by searching for it in Google, and then head over to that Burp Suite download website and go straight to downloads. Make sure it's community edition, is free. Click on download, and this is the downloading of the Burp Suite. After it's downloaded, just go to the downloads folder, and I've already uploaded it to VirusTotal to check, and it seems that it is not malicious. Now I'm going to cut it and put it in my own preferred folder, and I'm going to paste it here, and then I will double click the installer to start the installation process. Click on next button and take note of the installation path. I would recommend that you copy this installation path and save it somewhere. Now click on the next button. Click on the next button again. And now it has completed. Just click on the finish button To launch it, search for Burp Suite and then click on the button, the Burp Suite, to start the process. Over here, just uncheck the box and click I accept. And this is a temporary project, which is fine. Click on next button, and then here click on start burp button. Now we are going to perform some settings. Click on the proxy button, click on the options tab, and click on edit. By default, it is only capturing loopback. Click all interfaces and click OK. Click yes to confirm it. So now it is listening on all interfaces. Click on intercept, and when you are ready to start using it, click on this button, intercept on. When you finish, click intercept off. That's all on how to install Burp Suite and how to configure the settings. Thank you for watching. Hello and welcome back. In order to use the Burp Suite, we have to redirect all the traffic from the emulator to go through the Burp Suite proxy. So we have to set a proxy server setting for the emulator. So at the moment, let's open our emulator and then click this button to rotate the screen to become portrait. And then in order to redirect all traffic to the Burp Suite, we configure the emulator to use proxy. So we open a command prompt. So we are setting proxy server for the emulator. First, we have to find out the IP address. Burp Suite is going to reside on this computer, therefore we want the IP address of this computer. So to find the IP address of this computer, we type the command ipconfig and hit enter. Now this is the IP address that we are interested in, the wireless LAN Wi-Fi IP address. This is the internal LAN IP address. So take note of this IP address, 192.168.101.16. So in your case, this IP number would be different from mine. Just use the one that you see for your PC. So now that you've got this IP address, we have to test to see whether our emulator is able to access this IP address. So in order to test that, we have to open a command terminal in the LD player. So to open a command terminal, we first have to check whether our emulator is connected by typing the command adb devices, and we confirm the emulator is connected and visible from our PC. So now we have to use adb and connect to the LD player and try to ping this IP address, so that to confirm that the emulator can indeed access our computer. So we do adb and then shell. Now we got the root shell, we are connected to the LD player. So now we are inside the LD player, we are going to ping this IP address, which is our PC. So we can type ping, we can ping 2 times or 3 times. -C is count, and then followed by the IP address 192.168.101.16, and then we hit enter. And we see that there are responses, therefore this confirms that our emulator can access our laptop. So we can now use proxy server for the emulator to proxy to this IP address, our laptop, because Burp Suite will be running at this IP address in our laptop. So to do that, we type the command. We can exit first, and then type the command adb shell settings put global http_proxy, and then we copy this IP address, our laptop's IP address, selecting it and right clicking to copy, and then right clicking here to paste. So this is the command to set the global proxies for the emulator. So now after we enter this command, our emulator will redirect all traffic to this IP address, and then you hit enter. Now we are going to test. We will now open our Burp Suite, right click, search for Burp Suite, and then run it. So Burp Suite is going to intercept all the traffic from the emulator. Click on next, click on start Burp Suite, and then over here under proxy options, select this one, click edit, and we have to set the edit. We set Burp Suite to listen on all interfaces. Then we leave this at port 8080. It is OK, and then click OK. Click yes again, and now we go to the intercept here and turn it on. So now we will just navigate using the browser, Play Store, or we can use the browser, Chrome browser, and try to go to any IP address. So the default homepage is the LD Player Store. So we just click, and immediately you can see here it has intercepted the traffic from this emulator, because the emulator has redirected the traffic using the proxy server, which is the Burp Suite. So now you can forward this traffic to the intended server. So it is trying to reach this server, store US. We intercepted it. If we want to forward the traffic, we just forward it, click by this button, and it will forward the traffic. So you can keep on forwarding traffic until the whole thing is forwarded. Right, over here you can just click advance and then proceed to the store, and it intercept the traffic again. You forward again, keep on forwarding like that. Click proceed, keep on proceed, keep on forwarding. So it's intercepting every single traffic that is coming from the LD player. And then to see the history of all the intercepted traffic, you can turn intercept off and then go to HTTP history, and you can see all the traffic that has been intercepted. You can click this one to sort in ascending order. The earliest traffic intercepted is at the top. The most recent traffic intercepted is at the bottom. It is continuing to proxy the traffic even though your intercept is off. So intercept off, but the proxy server is still proxying the traffic. That's why you can see the number keeps increasing. To have a better view, you can sort it in descending order. Click on this, descending order, so that the latest traffic that has been proxied is at the top. As you can see here, it is already refreshed the page. So when you want to intercept, you turn it on again, and then it will intercept again. So when it intercepts the traffic, you are at liberty to do whatever you want to the traffic. Either you forward it, or you drop it, or you do something else. So this is how powerful Burp Suite can be when you are doing this hacking. So that's all for this video. Thank you for watching. Hello, welcome. I'm now going to show you how to install an insecure banking app, and then we can use this to test our Burp Suite. So go and download this from this website, Insecure Banking version 2. After installing this in our emulator, we are going to intercept the traffic, the HTTP traffic, using Burp Suite. So click on the releases button here and download the Android server zip as well as the Insecure Bank version 2 APK file. However, this version is only for Python 2. I advise you to use the version that I provide for Python 3, which you can download from the resources section for this lecture. But after you have downloaded, you can unzip it. Inside it you will find this readme file and the requirements. Remember to use the Android Lab Server version Python 3 that you can get from my website. So these are the requirements. So open this readme file, and here it tells you how to install, how to build it, how to build the dependencies. So the required libraries are listed here, all these 5. So you can use pip to install all these required libraries by using this command, pip install -r requirements.txt. So we'll open a command line. Remember that I'm using Python 3. So I type pip install -r requirements.txt, but before I do this, I should have changed to the correct folder that contains this Android Lab. So it does not run because I forgot to change directory. So I need to change to the correct directory. So now I've changed the correct directory, and I rerun the command I just rerun the pip command after changing to the correct directory. And now it is downloading the modules. So this command should have been run after you change to this directory. And this is the command that I ran after changing directory. So it is now building the modules that are required for this server. This is the server part. Our APK file is going to connect to this Python server. So that's why we need to install this Python server. So to run the Python server, we can change to the correct directory and type this command, python @py. So now you can try that. Clear screen and then list the directory. Confirm you have app.python there, that's the one. So we can type python app.py --help to see the help directory, the help content. So it doesn't run because this was built for Python 2. So that's why I asked you to download my version instead of download from the author's website. So go and download my version of this Android server, and you won't have this problem because I've already modified it. I've already modified this app.py to make it run on Python 3. So as you can see now, it keeps failing because this was built for Python 2. So what I did was I edited this to make it compatible with Python 3. That's why I I advise you to download my version instead of this version. So here you can see me doing the necessary changes to make it compatible with Python 3. There's a lot of things to change, and I've already changed it for you. So after you have downloaded my version, you can run it. You can use this Python @py --help, and you should be able to see this help. Then if you want to run the app itself, you just run Python @py, and it says the server is hosted on port 8888, and you can open your netstat command in the command prompt, and you can see confirm that it is running on port 8888. So now the server is running. You can now install the APK file that will be connecting to this server. This is the APK file which you need to install into the LD Player emulator. So we're now going to launch our LD Player emulator, and then rotate it to make it portrait mode. And then to install, we just drag the APK into the emulator. And now it is installed, we can double click to launch it. According to the author, the login, username and password is mentioned here. You can use Dinesh username and Dinesh @123 $ as a password. Or you can use Jack as a username and Jack @123 $ as a password. Before you can do this, you should set the preference, which I already done. I will show you in a while how to set the preference. This is the preference that you should set. The server IP should not be 10.022. It should be your IP address for your machine, for your laptop. So for me, my laptop is 192.168.101.16. Yours will be different. To find out your IP address, you type ipconfig, and for me it is this one, 192.168.101.16. So that is what I should put here. For your case, just follow what you see in your machine. After that, once you set it, the port is default 88, click submit. Now it won't log in because it needs a proxy server. So we will launch our burp suite. Click on next, click on start burp suite. Click on proxy, click on options, select the interface, click edit, set all interface, click OK, click yes. Now go to the intercept, click intercept on button, and now you try to log in. When you refresh, you can see it has intercepted the HTTP request. Now we type a test username and test password and click login. And you can see here, it has captured the test username and test password at the bottom here. So now we are going to put the correct username and password. At this point, I restarted everything again, and this time I put the correct username and password, and also the correct password here, Jack, as well as the Jack password. Click login, make sure intercept is on, and it intercepts it. Click forward to forward the thing, and you can see it has logged in. Rooted device, and you also can perform transfers and so on. So this is how you can install a vulnerable APK and also a vulnerable server, and then run the APK file and intercept it using burp suite intercept the HTTP traffic for analysis. So that's all for this video. Thank you for watching. Hello and welcome back. So I've already set the proxy server now for the Android emulator, as you can see. And now I will launch Burp Suite. Burp Suite will be the proxy server that will intercept the traffic. So I click Start Everything. And I'm going to set the proxy options, select the interface, edit all interface, and click OK. Click Yes. Then I will go to HTTP history to see if any traffic can be intercepted. Now I'll open the browser, Chrome browser, try to go to HTTPS website. And you can see it is blocked. HTTPS cannot be intercepted. So we export the CA certificate in DER format. Next, we want to install the certificate inside the emulator. So here we give a name for it. So click on button select file, and we give a name for our file. We go to this Swancher folder, which is the shared folder with the emulator, and we open the pictures folder and we put our name for the certificate here. We call it burp cert and click save. Then click on next, click close. Okay, so this is the shared folder that is being shared. So we just rename it to burpcert.cer. I forgot to put the .cer extension. So this shared folder is shared with the emulator here. You can click on the button there, click PC shared folder, and it will show you the folder that is shared. You click Android shared folder and you open the Android part, and that is where you can see in the Android part. So now you can install the certificate. So to do that, we will go to home directory first, and then click on this group, click on settings, click on Wi-Fi, click on the three dots on the top right, click on advanced, click on install certificates, and click on the last icon. And here go to the pictures folder, and there is your cert. So just click on it and give a name, call it burp cert, and click OK. Okay, click OK again. You need to set up a pin, so just select pin and just enter 1 2 3 4. Click the button continue and enter 1 2 3 4 again, and click OK. And here just click done. So now your certificate is installed, as you can see in the bottom right. So now we are going to test it. Go back and reopen. Okay, you may have to restart your LD Player emulator. So we do that. So now it's restarted. Let's try again. Open the Chrome browser and go to a HTTPS website, and it works. So now we can intercept HTTPS traffic. As you can see on the left side, all the traffic has been intercepted. Those are the HTTPS traffic. So that's how we can intercept HTTPS traffic, by installing the certificate for the Burp Suite into the emulator. Thank you for watching. Hello and welcome. In this video, I'm going to show you how to intercept traffic from this app, Mail RU dating app. and you will notice that this app communicates via HTTPS. And even though we already installed the certificate for Burp Suite, still it will fail. Let me just show you. So you can download this app from the resource section for this lecture. This is where I got it from. So after downloading this app, you can go and install it by dragging into your LD player emulator. And I've already set the proxy for this emulator. Now I'm going to run my Burp Suite. And I'm going to start Burp Suite. And I'm going to set the proxy options, edit, intercept, or interface. And now I'm going to look at the history to see whether it will be able to intercept. So now I'm going to run the dating app. And you see nothing happens. You get a blank screen here. And even here, you see it says your connection is not secure. Hackers can try to steal your personal data. Even though you click refresh, still you cannot connect, because it has got a higher level of security, so it cannot go through your proxy, even though you've already installed the Burp Suite certificate in the emulator. So how do we bypass this? So now I'm going to show you how to bypass this. So first we have to uninstall this. We have to patch this by changing the XML setting, network configuration setting. So let's close this first. So we have to decompile this first using APK2 and then patch the XML, one of the XML files. So let's copy this path and then open your command prompt and navigate, right clicking, and then you type apk2 d for decompile followed by the name of the app. Hit enter. Now it has decompiled it. There is a new folder. If you enter this and open XML file, the Android manifest, and scroll down, look for the applications tag over here. If you look to the right here, you should be able to see Android network security config. So this file is preventing us from intercepting the traffic in Burp Suite. So we should modify it. So it is located in this folder XML. So if we head over to XML folder, under REST, there is an XML folder. REST stands for resource. And here, this file is preventing us. So we should put this file inside here. So this file is the one we need. So we need to change this. Go to the back here and remove the debug. Rename this to the correct file, network security config, and then save it. If the file does not exist, we should add it manually. Supposing you don't see this thing here, supposing this was missing, then you have to add this manually and also create this file manually. But at the moment the file is already existing, so we just have to modify the contents. So let's go and take a look at the contents of that file, which is this one. and you see here it says debug overrides. So we need to change this tag XML text to our own. So you can get the copy from the resource section for this lecture. I already provided the correct text for you. So you can download this file from the resource section and unzip it. Then inside here you see some files. So this is the one that we want. So we just open this. So what we do is we copy everything from here to here. Copy all this and then paste it into the original one over here to overwrite this one, this part here. Delete this and paste our own code. So we are telling the application to recognize our user certificate which we install inside the emulator. That is what it's doing. After that, you need to save this and then you need to rebuild everything. So to rebuild it, use the apk2 command, type B for build and then the name of the folder and hit enter. If you see an error, then you use AAPT2. But if there's no error, then you don't have to use this. Just hit enter, and if there's no error, then you don't need to do that. So hit enter now, and it's going to rebuild everything. So now it has completed building, and let's try to locate the file. The file should be inside the distribution folder. Here, it's a new folder that's just been created. So this is the new APK file that has been patched with the new XML. So let's try to install it. You say you cannot install because it has not been signed, no signature. So you need to sign it using the jar signer. And before you can sign it, you need to create a key store. So we will continue in the next video where I'll show you how to create a key store and also how to sign it and also go ahead and test it. So that's all for this video. See you in the next one. Welcome back. In the previous lecture, we already modified the XML configuration for this file, for this app, and we already rebuilt it using APK2, and we found that when we try to install it, it says there is no signature. So in this video, we are going to create the key store and then use that to sign this APK file. So you can download the command to create key store from the resource section for this lecture. So we are now in this location, the RU dating app directory. So let us navigate into this folder. And we are going to create our key store inside this distribution folder inside here. So the command to create a key store, just copy this and paste it in here from the resource section, the files that I provide for you. So the command is called key2. Key2 is a command, -gen key, -v, -key store, and then the name of the key store that you want to create. And then here, -alias, my key. Normally my key will be the same as the name of the key store. And then at the back, -key alg. alg is an algorithm. You then provide RSA as a parameter, and then -key size. So the key size is 2048, and then -validity, put 10,000. That's it. So now you hit enter, and you ask for a password. Just give any 6-digit number, 1, 2, 3, 4, 5, 6. Enter. Again, 1, 2, 3, 4, 5, 6, enter. And then here just press enter, 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 enter. And then here type yes, Y-E-S, yes. That's it. So now you have a new key store. If you come back and see, that's your key store. So now we use this to sign this app. So to sign, we use another command. Let me clear the screen first. So you can copy and paste this command. I also provide for you the signing command. So we use the command jar signer dash verbose dash sig alg sha underscore sha with rsa. This is sha1, and then digest alg sha1 dash key store, and then the name of your key store file. So this file here should be the same name as this file here, and then finally the app, and then the alias. So the app name in this case is this app. So just type in ru, that's app, and then the last parameter is your alias. So the alias is my key. So that is the alias we used to create this key store. So now you hit enter, and you ask for the password 1, 2, 3, 4, 5, 6, and one more time, and that's it. So now it's signing everything. Yes, so you see jar sign. Okay, so now you can install this on your, we can close this. So we drag this and install it in our LD player, and successfully installed. Now we'll start our Burp Suite. So search Burp Suite. Click next, start Burp Suite. And then here under proxy, select options, select interface, edit, and select all interfaces. Click OK, click yes, and then click HTTP history, and now we'll see. Let's run this. And there you go. It is intercepting the HTTPS traffic, as you can see. There you go. Now it's working. Alright. And then you can even intercept it. You go to intercept, click intercept on, and then here click register your email. So whenever it's intercept, you need to forward it. Okay. And here click register your email, and it intercept that as well. See that? Forward again, and so on and so forth. So now you're able to intercept all the HTTP traffic for this app. So that's all for this video. So we have learned how to intercept HTTPS traffic by modifying the network configuration settings for the app itself, and using APK2 and jar signer. So that's all for this video. Thank you for watching. Welcome back. In this video, we are going to take a look at insecure local data storage vulnerabilities, and we are going to make use of the insecure bank version 2, which we studied earlier before, which we downloaded some lessons ago. So now I've already started my LD player, and I'm going to set it to portrait mode, and this is the target application, insecure banking app, but this requires a server to log in. So let us log in. Let us start the server side. Just to remind you, this is the Android Lab server for Python 3, which I created for you. You can re-download this from the resource section if you need. So you need to enter this folder and start this server at app.py. So let us copy this first, and open our command prompt. Navigate to that directory and type python app.py. Hit enter, and it is started on port 8888. The other thing we need to do is to turn off the proxy server so that we don't have to redirect to Burp Suite, since we are not using Burp Suite for this exercise. So to turn off the proxy server, we will open another command prompt, and in here we will type adb devices to make sure that the device can be detected by adb, and there is the emulator 5554, which is our LD player. So to turn off the proxy server, we need to issue a command, which I'll paste here. adb shell settings put global http proxy :0, and now we hit enter, and now we will turn off the proxy server. So now we can run our insecure banking app, and we need to set the IP of the server. So click on these three dots here, click preferences. So to find out this IP, we come back to our command prompt and type ipconfig, hit enter, and you can see that our server IP is the wireless LAN adapter Wi-Fi IP, which is this one. So I'll replace this with my IP 192.168.101.16. Yours will be different from mine, so just follow what you see for your case. So now the port is 8888, make sure it's the same as the one which is listening on, then you hit submit. Now to double check that it is the server is actually running, so I will clear the screen first and type the netstat command. And if you scroll up, you can see port 8888 should be there. So this confirms that the server is running. Okay, now we can log in. We can log in using the developer provided login name. So if you have forgotten it, let me just refresh your memory by going to the developer site, the developer for this insecure banking app. So if you head over to this location, insecure bank GitHub, and scroll down, you can see that the credential is as follows. You can use either Dinesh as a username and Dinesh at $123 as the password, or Jack as a username and Jack at $123. So choose either one as a login name. So let's use Jack, and the password is Jack at $123. Click login. So now you have logged in. So now you can go and analyze where the data is stored locally. So you open a command prompt again, another new command prompt. Don't use this one because this one is the server. So open a new command prompt. Type adb devices one more time to list the device that is available for adb. Then open a shell to it, and you get a root shell. So now we go to the /data to see all the installed devices, all the installed applications folders. So type ls to list them all. And then the one that we're interested in is insecure bank app, which is over here. So we should enter that directory and then see the content. So we type cd com.android insecure bank2 app. So now we hit enter and hit enter the directory. Let me clear the screen. Now we type ls, we can see all the folders for this application, and the one which is interesting are the databases and the shared preferences. So we can enter the shared preferences by typing cd followed by the name and then type ls. And here we can see very interesting information. This one, my shared preferences.xml. So to view that, we can type cat. Cat is a text viewer, and there you go. Let me repeat that for you since it's not clear. So ls, type cat, and then followed by the name of the file. Cat, followed by the name of the file, hit enter. And here you can see this is an XML file. You have the string name, encrypted username is this, is a string, and then you also have the super secure password, which is this string over here. Right, so this is some kind of local data that can leak information for hackers. Alright, so now we're done with that. Let's go back to the parent folder by typing cd space ls, and now we can take a look at the database. So let us enter the database now. Let me clear the screen first. Enter the database ls, and you will see there is a database called mydb. We can use SQLite 3. So SQLite 3 got the help there. If you need more help, you type .help and you can see the commands for SQLite. SQLite is used for querying databases, so these are all the commands, and the one we're interested in is table. So if you look at this, .tables, yes. So .tables will show you the available to exit. You type Ctrl D to exit. Okay, so let's clear the screen now. So now we want to connect to MyDB, so we type SQLite 3 followed by the database name, which is MyDB. So now you're connected to MyDB, and now you can type the .tables command as we saw earlier. This will show you all the existing tables inside this database. So there's the metadata and the names, so we're interested in the names. So we can execute a SQL command to extract all the names in the names table. So we type select star means everything, every column. Select every column from the table name. So the table name is names. So hit semicolon and then hit enter, and you can see it has selected this database Jack. So to quit, you just Ctrl D and then you quit. So this is how you can use this commands ADB shell to query the local data storage to look for additional data information leak. Thank you for watching. I'll see you in the next one. Welcome back. In this lesson, we are going to take a look at exported components vulnerabilities and how we can exploit them. So for that, we are going to make use of this Insecure Bank app, which we already installed from some earlier lessons. And in order to run this, we need to also run the client and the server part. So the server part, you can actually download both again from the resource section, and then you can unpack and put it in a suitable folder for the server. So mine is placed in this directory here, and if I dir, you can see the unpack part. So we need to run the server. To run the server, we type python app.py, hit enter. So now it's running on port 8888. And then for the client part, we need to set the preferences by clicking these three dots and click on preferences and click the server IP. The server IP is a server for my laptop. It's my IP for my laptop, so we need to check it. So we open another command prompt and type ipconfig, and you see my Wi-Fi LAN adapter Wi-Fi IP is 192.168.101.16. So I'll fill it here. .101.16. Make sure it's correct, and then click submit. Now you have to make sure you are not proxying this to a burp suite. So if you have previously proxied this burp suite, you have to set the proxy to off. So the proxy to off, I've already showed you in how to turn it off in one of the previous lessons. So now the credentials for this, you can log in, and before we log in, we want to see what are the exported components. So exported components are found in the Android manifest file. So in order to see the exported components, we have to decompile this APK file. So I'm going to do that now by heading over to the projects folder. So this is the APK file. So to decompile it, we use APK tool. So I'll copy the path for this first, then I'll CD to that path, clear the screen, and then type apk2 followed by the app, and then hit enter. Okay, so now it has decompiled, as you can see here. Insecure bank app. Note that there are two ways to decompile it. You can type it like this, or you can put D here. D for decompile. So now you can open the Insecure Bank app, look at the manifest, and how do you know which component is exported? You look at activities. So over here you can see this activity has got an intent filter. That means this activity, login activity, is exported. Another one is where you have exported through in the tag. This also means that this activity is exported .post login. So whenever you see either an intent filter or you see exported through, it means that that activity is exported. So since the activity is exported, you can remotely call the activity to run. So that is a vulnerability. This is called components. Activities are components, and if it's exported, then that is a vulnerability. So now you can try to log in. So let's go back to this and log in. So the login name I've already mentioned. You can use either Jack or Dinesh. If you have forgotten what they are, you can take a look at the notes for this lecture, which you can download. So the credentials can be this or this, so we use one of them. Let's say you log in as Jack, and the password is Jack at $123. Now we hit enter, we log in. So now we are logged in. So that happened because of this activity called login activity over here. So now the vulnerability is, if we were to call this post login remotely, we can bypass the login. So let's take a look. So over here, supposing the user did not log out. The user didn't log out. The user just did this. And then now if we want to remotely bypass the login, we can remotely call this post login activity, because this post login activity, the exported is equals to true. So how do we call this post login remotely? We can open a command prompt, and then over here we type ADB devices first to make sure that the emulator can be detected by the ADB tool, and then we issue this command ADB shell, this entire command here. So I'm just going to copy. You can download this from my resource section for this lecture, and we just paste it here. So ADB shell is to remotely connect to the emulator, and then you want to start this activity by the name, -n is a name, and com.android.insecure bank version 2. So this is the package name. If you have forgotten the package name, you can just do a shell first, ADB shell, and then from here you can navigate to data and list, and you can get the package name from here. So this is your package name, insecure bank, com.android.insecure bank version 2. Okay, so now I'll log out again, and I will paste the earlier command. So the syntax is like this. You name the package name, put a /, and you must put a dot followed by the activity that you want to call remotely. So now you take a look. The user has already abandoned the login, has already logged in previously, and now has already abandoned the app. But we can remotely bypass login by calling the post login activity, and you can see we have bypassed the login. So this is known as the insecure exported component vulnerability. So this is an example of a component called activities. Besides activities, you also have receiver, you also have content provider. So receiver is another one of the vulnerability. If there's an intent there, that means this receiver broadcast is also a vulnerability and can be received, and you can make use of this remotely. Another one is content. Content is not shown here, but one of the inherent content vulnerability is SMS. So for SMS content vulnerability, we can exploit it by the same way, but slightly different syntax. So the syntax for that is this: content query URI content SMS. So we will copy this now, and over here we come back to our shell, and we log in, and then we paste this and hit enter. Look, we managed to query this SMS inbox, right? Because this particular device has no SMS messages, so that's why it says no result found. But there was no error. That means we successfully exploited this content provider vulnerability. So that's all for this lecture, this video, where we have looked at how to exploit the exported components vulnerability for hacking. Thank you for watching. Hello and welcome back. In this video, we are going to explore insecure logging. What is insecure logging? In development, normally it is very common for programmers to use debug logging for purposes of debugging, and sometimes these debug logging capabilities are also left behind in the production applications. So we can take advantage of that to get some useful data. So over here we are going to make use of the insecure banking app, which is over here. So you need to first start your server for this insecure banking app. So this is the server, the Android Lab server. Copy this path here and head over to the command prompt. Change directory to the server location and fire up the server. should be a Python script. Now the server is running. The next thing you do is to set the IP address for the server here. Click on the three dots. Under preferences, to get the IP address, you open up another command prompt and type the IP config to list the IP address of the wireless LAN adapter, which is 192.168.101.16. 192.168.101.16. Click submit. And then if you wanted to be sure, you can netstat -dan to make sure the server is running on port 8888 over here. Then you can also ADB shell into this. First you type ADB devices, make sure the emulator is there, detectable, and then you ADB shell to connect to the emulator, login, and then now you will ping the server. The server is 192.168.101.16, just to make sure it's accessible from the emulator. Okay, so that's done. Now you can exit this. Let's clear the screen. So in order to grab hold of the log files, the logging capabilities, first we must clear the logs. We use the command adb logcat and -c to clear the logs so that we can start afresh. So these are the commands you can download from the resource section. adb logcat -c is to clear the logs, and the next thing you want to do is to log in over here with the username. So the username you are searching for is Jack, assuming you are logging as Jack. So over here, if the user were to log in with the actual username and the actual password, which is this one, this is the password, and then over here we can start the logcat, adb logcat, and pipe it to the find string command, which will search for any username with Jack so we can steal the password. So now we hit enter. So now we hit enter, and now it is waiting for the log. So over here the user will click on the login button and immediately it captures this password, jack@123$. So this is how dangerous it is to leave behind debug logs capability in production applications. That's all for this video. Thank you for watching. Hello and welcome back. We are now still at the uncrackable crack me one, and as you have seen before, if you just run it, you get the message say root detected. This is unacceptable. And in this lesson, I'm going to show you how to bypass root detection using objection. So let's close this now, and let's type the command objection. So before that, we need to get the name of the package. So we type Frida PS UAI and hit enter, and we see here the name of the package, which is OWASP MSTG uncrackable one. So we select this, right click on it to copy the package name, and then we type objection. Now we must give the -G the name of the gadget, and then right click to paste the name of the package. And then after that, we will type explore. So this already I've shown before. If you just hit enter now, it's going to connect to this and start the application. And however, you will give the message root detected. So objection has got a built-in capability to bypass root detection. So let me show you how it's done. So let's exit the objection shell first. I forgot to mention that before running objection command, you have to make sure that the Frida server is running. So now let me show you how to use the objection root bypass command. So after explore, if you were to type -H and hit enter, it will show you the help. --help. It will show you the help. So part of the options that are available after explore is to have the -S startup command. That means you can specify a command that is to be run when objection starts. So to do that, we can put the -S after explore and then put the command that we want to execute here. So one of the command that we can use is Android root disable. If we did this, then it will bypass root detection. So let's try and see. Hit enter, and you see it fails to bypass root detection. Now this is probably because the app was running too fast for objection to put the hooks. That is why the root was detected even before this command can run. So as you can see, the command was successfully registered, root detection disabled, but it was not fast enough to hook the root detection. So we need to find a way to delay the APK. So one trick is to use Frida to start the APK in a pause state. Then we'll inject the hook. Alright, with objection. So now let us try that. So I'm going to exit this, and I'm going to repeat the same command over here, getting it ready, but don't press enter yet. We want to use Frida to pause this in a pause state. So let's try that now. Open another terminal and go to the command prompt. And here we use Frida to start our app. The name of the app, if you have forgotten, you have to list it again. And over here, you get the name, copy the package name here, and then type Frida -u -f, as we have done so many times before. So once here, you just hit enter, it will launch the app and enter the pause state or the suspended state. You see that? It's suspended state and it's waiting for you to type resume. But don't type resume yet. Come back to the other terminal where your objection command is waiting. Now over here, we hit enter. So once you hit enter, it will inject this command into the process and get ready to run it, the root detection disable command. So over here, we come back to the Frida now and then resume it. So when you hit resume, watch what happens. It already bypassed the root. And you can see the output here in the objection terminal. So this is how it bypassed the root detection. See this? File existence check for this, false, 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 and so on. So how does it work? All these are part of the checks used inside the root detection mechanism inside this APK file. And these are quite standard used in nearly most of the APK files when they are performing root detection. So that is why objection has got this built-in bypass for this type of common checks for APK files. That's why it can work. So this is another easy way to bypass root detection without having to write a lot of low-level scripts as we have done before in Frida scripting. So that's all for this video. Thank you for watching. Hello and welcome back. In the previous lesson, I showed you how to use objection to bypass root detection. And in this lesson, I'm going to show you how to run Frida scripts after you have bypassed root detection using objection. So let me just repeat the root bypass using objection. So over here we have two terminals open, one with the Frida command to start the APK file and pause it. So I'll run this first. And then now I'll go to my other terminal and bypass the root detection using objection. So now I will come back here and resume. And it has bypassed the root detection, as you can see. So now what we want to do is to run the decryption script. As you can remember, the decryption script is decrypt and show. Okay, so now we are going to run this script from the Frida session because the objection session has quit by itself. So coming back to the Frida screen, how can we run this decrypt and show? In the previous lesson, earlier lessons, I've already shown you how to load the script during runtime by using command such as this. And then load the script using the -L. Okay, this was what we did previously. We loaded the script at the start when we were calling Frida-UF. But now Frida is already started. How are we going to run the script? Decrypt and show. So we can use the exec command. So let me show you. First we type the %. You can see the available commands. The exec command allows you to run scripts once the Frida terminal has opened. So we can just type help to see the available commands. So help shows you, %help shows you this help, and you can see here execute the given file path in the context of the currently loaded script. Okay, so that's what we want. So we put %exec and then the name of the script, decrypt and show.js. Then we hit enter. And you can see it has ran the script and show us the password. So we can copy this and paste in here like how we did last time, or you can just type it in and hit verify and it's correct. Okay, so this is how you can use objection to bypass the root detection, and after you have bypassed it, you can come back to your Frida terminal and continue working with your APK file, with your process. So that's all for this video. Thank you for watching. Congratulations on completing the course. Thank you once again for taking this course. Please remember to keep me updated on your progress or anything else that I can help you with. Meanwhile, here are my other courses which might interest you. Number 1. Learn ethical hacking by hacking real websites legally, Part 2. Learn ethical hacking by hacking real websites legally, Part 1. Internet of Things, IoT, robotics, and hacking with Node MCU. How to monetize your Construct2 games using AdMob Ads 2020. Android mobile app development with Onsen UI and PhoneGap. Monetize your mobile PhoneGap apps using AdMob Ads 2020. Create mobile app icons using Inkscape. That is all from me, and I wish you all the best and hope to see you again in my future courses. Thank you.